Me refresca Hello and welcome back to our live coverage of the Rosetta Philae landing on the comet Churyumov-Gerasimenko. I'm Monica Jones at the European Space Agency. We already had the 4 go decisions. We had a successful trajectory maneuver, and just 2 hours ago we had a successful separation. Here's what's happened in that moment of separation.
Yes!
Yes! Time to separate. It was nice meeting you.
So clearly a lot of relief there, crucial moment during the 7-hour descent, but we're still waiting for the signal, which we expect any moment. So let's not waste any time and cross live to the main control room now to watch the action going on there now.
Still separated.
So from telemetry, it appears that the lander hasn't come back. So it's still separate.
We didn't get cold feet. Because he plays for 10 years.
This is very easy to recognize. Otherwise, we have to take it down. Right, and that was expected. So the is set by the ESS. the best is the packet arrival. Okay, we see also the arrival.
But you get the carry on it.
Yeah, exactly.
But we have ESA.
Yes. Start getting it in an hour from now.
When we have problems, you see. Wait for my go.
There is one main nominal initiation. The system is initiated. I think it's what the procedure says. I think we see a believe with CRM. Is there one sequences? Yeah. No, this is yes. We haven't figured out everything of the ESA system. Just figured out their speed. Was it initiated or went back to idle? The ESS. Research. I think it was seen. I mean, I stick with what is written in procedure was seen, signal, but he couldn't initiate the link. However, that went back to research. Yeah, that's correct.
I see stuff.
Yes, yes.
Yes. We got it.
Yeah, this is the one. Yes, still alive. That's the one. Still not. Yes.
Still not separated.
All the workstations receive under
Yes, we have the link is there.
Come down.
ESA or speaking.
Yes.
Can I talk to them? LCC, this is on your room.
Yes.
Okay, we see. See telemetry.
System check this.
Affirmative. We see data, housekeeping data from the lander. We see the mechanical separation switches from the lander working separated. And we have the RF parameters of the ESS telemetry housekeeping report successfully. We definitely have telemetry from the lander. You're welcome. Congratulations.
Here, I can hear that Paolo Ferri, the head of ESA's operations department, who we just saw next to flight director Andrea Accomazzo, is ready to confirm, hopefully, what we've just seen. Paolo, please tell us, what is the status?
Yes, we got telemetry from the lander. This is a very, very important moment. It's established, the link is there. Now we can follow it on its descent.
Fantastic. We'll wait for a second signal, if I'm correct?
No, we are very happy with the signal we have. We receive telemetry on a periodic basis. So, yeah, now we can sit down and wait for the initial data to come, like pictures and other information from the lander over the next 5 hours until descent, until touchdown.
Hey, just for me to write down, please confirm we have a signal from both Rosetta and the lander.
Oh, yes, of course. The signal from Rosetta was acquired earlier on. And now Rosetta has confirmed that Rosetta is receiving signal from the lander. We can see the telemetry from the lander on our displays. We have an end-to-end link established. That's exactly what we wanted.
Brilliant. Congratulations. That's really good news, Paolo Ferri. Good luck in the next 4 hours when we have the next crucial moment. Thank you very much.
Thank you.
Well, so another major hurdle taken, but of course this mission is so much bigger than just one hurdle at a time. May I give you one microphone? There's another one over there. I'm here with two gentlemen now. They're both, I hope I'm allowed to say, in their 70s. And I certainly don't, I think with gentlemen you can say that. And I also believe I don't exaggerate when I say without either of you, Rosetta wouldn't exist. Welcome, Roger Bonnet, the former ESA Director of Science Program and Director of ISSI, and Bernd Feuerbacher, the former project leader of the Philae Consortium at DLR. Good to have you here with us. I would like to start with you, Mr. Bonnet. When you were the Director of Science at the European Space Agency 3 decades ago, I should think that the European Space Agency looked somewhat different from now. How did the Rosetta mission evolve in your?
Well, when I started my duties at ESA in 1983, ESA was just an agency with no plan. It was mission after the next, and but it built up its own future universe at that time, and so we decided to make a plan, a survey of 20 years. and to present that to the ministers in Rome in 1985. And the plan was judged to be good and sane. And it satisfied the 2,000 scientists in Europe, unifying the astronomers and the people who want to look at comets and the people who want to look at the sun. Usually these guys are fighting to get their mission approved. With the magic of this long-term plan called Horizon 2000, we managed to get the whole community unified behind this plan. So this was the difference between pre-83 and after 83. And Rosetta, of course, was part of the 4 pillars which built this long-term plan called Horizon 2000.
Of course, I mean, you mentioned there is so much to explore in space, and you have to make decisions. Were you personally in favor of the Rosetta mission?
I was in favor of Rosetta for the very good case that, in fact, why did we have Rosetta in this plan, in this long-term plan, in this 20 years plan? It's because my predecessor, Professor Trendelenburg in ESA, decided to have a mission to a comet called Giotto. And this was also a fantastic mission, I tell you. Very, very risky, even more risky maybe than Rosetta, because we were fighting against a comet which was riding to us at a velocity of 70 kilometers per second with a small camera with not the same number of pixels that we have today. And we managed to do that. So the whole community was geared toward exploring comets. And when we said, what do you want to do in the future, in the 20 years to come? Well, 500 scientists said, we want to go to a comet. They did not know how to do that. So we said in ESA, you will go to a comet, but you have only 400 million euros to do that. Do it. It was hard for them to define what Rosetta would be.
I bet.
It took more than 10 years for that, but they did it. And it's
and 400 million euros, that's an interesting figure.
At that time.
At the time. And we're just talking about Rosetta at this moment. Mr. Feuerbach, there's, of course, also the lander. I mean, everybody today is talking mostly about the lander. When and how did Philae come into play?
I mean, the idea to land was always there. Originally, it was even planned to go to a comet, take a sample, bring it back to us, and investigate it on ground. But then that was joined with NASA, and NASA stepped out, and you investigated even to have a lander with a purely European mission, but that didn't fit into the 400,000, right? So it was really a couple of scientists that got together and said, look, if we're flying to a comet, we should land. And it was in a meeting with the German Space Agency where we tried to convince them to fund a lander in industry, and they thought it was too expensive. And then 2 people, Helmut Rosenbauer, who unfortunately cannot be with us here today, and myself, we said, okay, if they can't do it, let's try to do it ourselves.
We see a picture of Helmut Rosenbauer here, who due to health reasons can't share this moment now, but he is one of the co-fathers of Philae, if one may say so.
Yeah. It was really these 2 people that took the decision, and we got together a consortium of about 24 scientific institutes in Europe, which came together and actually made this Philae, which is now flying there and even talks to us now.
It even talks to us now. But was it a good way to go this way? Because I believe Philae did have some birth difficulties as well. I had to do with the mechanics already at an early stage, trying to figure out how to best go about it.
I mean, Philae had many problems. It is unique that it actually has been built by scientific institutes, which were not really meant for it. And it was people like him who really put the gun at us and said, look, people, either you do it properly or we will cancel you. And he was serious about that. And that actually changed the situation. And ESA was very helpful. Then we got some help, and we got some professional help from industry, and that's the way we could really get Philae to the success that we have now.
So it's thanks to the stern voice of Mr. Bonnet that things were running fairly smoothly, actually, throughout the past 10 years, all things considered.
That's the way it looks now.
You know, the history books, you know, you always have to take them with a pinch of salt.
For the sake of being faithful to history, I was not the only one to knock on the shoulders of this guy, because I had engineers, who, some of them are still in the room today, who were very good, very strong. From all countries in Europe. Can you see that? The success of this mission is a European success. We have Italian operators, we have British project managers, we have scientists from all Europe. Really, it's truly international. It's wonderful.
It's international, but if you compare it to the science of 30 years ago and look at science today, what's the major difference, would you say?
Well, of course, the technology has made enormous progress. As I said, the Giotto camera had only a few pixels on its CCD. Now we have several thousands of pixels on the camera of Philae. The technology is different. Also, the people have learned to work together. The one thing which I would say is different, with due respect to our American colleagues, is that before 1983, we were totally dependent from the US to launch our missions and to go to ambitious programs. After 1983, and this was due to two facts. First, the success of the Ariane launcher in '79, which gave Europe the sense that it could go into space by itself. The second problem was a big crisis between Europe and ESA and NASA about the International Solar Polar mission, a mission with two satellites, one flying above the pole of South Pole of the Sun, the other one above the North Pole of the Sun. For financial reasons, but in a way which was not necessarily the best way. It was announced through the press, we learned it through the press, that Ulysses, now called Ulysses, this mission, the Americans had dropped from it. So we were not very happy, and this made it possible that we design a program purely European. The fantastic miracle of this program is that as soon as it was approved in a purely independent framework of any other cooperation, everybody came to us and said, can we join? So instead of begging hospitality on other missions, we were offering hospitality on our missions. And this is the story of this program, which is now so different from what we had 30 years ago.
And luckily, too many cooks in this case did not spoil the broth. Finally, just in one sentence, one last remark, your wishes for this mission now?
I wish we discover the molecule of the DNA of life on Earth.
And you?
Let's have a safe landing.
Very good. Very good. I'm all with you there. Thank you very much, gentlemen, Roger Bonnet and Bernd Feuerbacher. Good to speak to you. And of course, we have, from the more mature generation, we moved to the young generation of scientists, because obviously there was so much interest, certainly throughout this year, in the Rosetta project, that the European Space Agency went a step further in order to nurture this interest even more by coming up with 3 competitions surrounding the whole project, and we have some of the winners here with us of these competitions. And I'm sorry, I have to leave you for a second because I actually have to grab a microphone, because otherwise you can not talk to me. I would like to introduce you to the winners that we have here. Right in front of me, here, right here, is Dimitrios Grillis from Pallini in Greece. You're the youngest, I would take it, of all of us here. And you won the first prize for the video entry for the Rosetta Wake Up. And we do have a little clip. Let's take a look at that one now. Brilliant. Congratulations, Dimitrios. We also have Josef Dobrolowski from Poland. Hands up, that's you. You won the second prize, also for the Wake Up, so congratulations for that. We have Emanuela Andreola from Italy. That's you, it's Emanuele, of course. Number 1 entry for the Rosetta, Are We There Yet? And I believe we have a still of a picture that shows you here. at 4,061 meters above sea level, if that's correct. So that's identical to the size of the comet we are flying to. So that is brilliant. Congratulations. And also from Italy, Elisabetta Buonora. Now that is easy for me to find out. That must be you. You won the second prize also for Are We There Yet? Congratulations. And last but not least, the gentleman standing here. Step a bit forward, I'm not quite sure if I can see you otherwise. Alexandre Broust from France, who just a few days ago actually proposed the name for the landing site, formerly known as J, and now it's named Agilkia, which is the island on the River Nile and home of the temples of Philae. That is a fitting name. I know that you are a scientist, you're studying it, but what prompted you to actually take part in the competition and come up with a name that's got nothing to do with maths, which is obviously your main topic?
So actually, I'm teaching it.
You're teaching? Okay.
So I'm interested by space activity since a long time, and recently I went to some exhibition, art and science exhibition in CNES in France. And one of the artists who were there told me about this contest. So I look at the site, and I remember some of my ancient Greek readings and some of French author readings also. And I knew about Philae, so I made some research, and then I put my name, Agilkia, and I'm here in Darmstadt.
Fantastic. And I like the combination art and science, because we often think of scientists as dry and boring. I think the Rosetta mission has shown that's not the case, and your entry has also shown that. Congratulations. And I think that's worth a round of applause. Really wonderful. Thank you very much. It's good to see so much young talent. And I have a gentleman here with me now. You can come a bit closer. I give you the microphone. Mario Salati from the Agenzia Spaziale Italiana, ASI. Quite inspiring. Any comments you would like to make about these young people?
It's such a great pleasure to see those young people on the stage today. And what's the most important untold goal of every space mission that we've done? Yeah. To inspire. That's to inspire people, to inspire younger generation. So
and I believe the contribution, ASI's contribution to this project.
Yeah, think of the inspired people who designed this concept of this drilling tool that can allow, hopefully, Philae to dig into the surface up to 23 centimeters, be able to grab some of the material which is underneath, and then bring it back to the laboratories that we have on board of the Philae spacecraft in order to make the analysis that we would have liked to have done, of course, on Earth if we had a return mission, but this is not the case. So we sent a laboratory over there, and the drill that we proposed, and in fact it was the final choice actually, is a system that not only is able to get to the point where to take the material, then give it to the instruments that have to make this analysis. This is fantastic. And on top of this heritage, we are building a new one that will be employed on Mars in next mission from ESA on Mars.
Okay, well, but before we get to that mission, I keep my fingers crossed that your drill will get into action very soon, that everything is going well. Mario Salati, thank you very much. I'll just grab this. Be inspired, definitely. Thank you. Mario Salati from ASI in Italy. And I hear that we have a bit of news from the main control room, where the Philae lander manager, Stefan Ulla-Metz, is standing by. He has the telemetry data which he receives. What's the latest there? Tell us.
Yeah, indeed, we received telemetry. We know the flywheel is still spinning. We have the nominal bus voltage. The landing gear has been deployed. So everything looks nominal right at the moment. That's very good news indeed.
Okay, comforting news during the descent that is still going on. Stefan Ulla-Metz, thank you very much. Thanks. We'll check with you later again. Of course, this is all nail-biting stuff as we approach the actual landing. And there are a lot of people here in the room and on the compound of the European Space Agency, but also in the other operation centers. And let's cross over to one now, the Lander Control Center in Cologne. Principal investigators, co-investigators of at least 10 instruments of the lander are there. And standing somewhere there, hopefully very soon visible for us, would be, three gentlemen. Hermann Böhnhardt, I would like to start with. Hands up, who is Hermann Böhnhardt, that I can actually see him and address him. Wonderful, you're right in the middle. The other two gentlemen, please don't be upset with me if I don't introduce you straight away. Too much information right now. Hermann Böhnhardt, one of the two Philae lead scientists at the Max Planck Institute in Göttingen, Germany, of course, and the scientists next to you, and certainly those behind you, they represent the variety and diversity of the mission. What's the mood like?
Well, the mood is very good. We have about almost 100 people here from the scientific community of the lander, from almost 50 countries and 50 institutes and 17 countries in Europe and in the world. So we are a big community, and we get more and more excited, and we were really applauding here at the time when we heard that the signal came back from the lander to the orbiter, and expectations is really rising.
What is your role as a lead scientist in the project? Did you get that?
Yes, I got it. My role is to try to foster the science of the lander. It's a 10-instrument adventure, and we have to somehow balance the contribution of the instruments in terms of priority, to give them also the space and the time and the power to really make the measurement. And this is all done in the past years, and it is sometimes an exciting process because we learn about the scientific goals which we follow, and we have to understand the instruments that are supposed to do that, and then also balance this a bit. I talk about the PIs of the instrument, but also the lead scientist, Jean-Pierre Bibring, and me. We have somehow to find a way through this competition of science that is happening, and with the aim to get the highest benefit for the outcome of the mission.
Okay. Before we get to the two other gentlemen who are standing there with you, Klaus Seidensticker from the German Space Agency and István Apati from the Scientific Institute of Hungary in Budapest, a couple more questions perhaps for you, Hermann. Obviously, I mean, you've been also involved for quite some time. Is there any experiment there that you would say is closest to your heart?
Yeah, I joined the lander community 10 years ago, so I was not there from the beginning, but I'm in cometary science in the beginning, and for me most attractive is the questions that are related with the origin of our planetary system, plus what is in the planetary system, and it's mostly us on Earth. I think we feel we are most important here, but that's what attracts me. So what is in the planetary system and how it was formed, CONSAT is an important instrument for me to answer this. And because it can look into the interior and tell most likely how this comet was formed. And this helps us also for the understanding not only of our planetary system, but I think also of the exoplanet systems that exist in the universe. And the other question that is related with us is the water on Earth, of course. There we have Ptolemy, that is an instrument that can address this very well with the isotopy, and even beyond that, where the comet was formed. So the location in the planetary system will be constrained by this instrument. This is very, very important in my opinion. And last but not least are the questions of organics, which is open since years. I just like to remind you, when the first cometary spectra were taken more than 100 years ago, they found C2 and C3 molecules. Where these molecules come from, they are obviously organic origin, but we still don't know that, and I hope Rosetta will answer this question.
Okay, well, let's hope that we get to that, because that would also give astrobiology a boost, and many, many other parts of the scientific community will be thankful as well. Hermann Böhnhardt from Max Planck Institute, thank you for now, because now I would like to turn to Mr. Klaus Seidensticker, who is standing next to you in the yellow jacket, if I am correctly confirmed, from the German Space Agency, and you, of course, are the principal investigator of the Sesame instrument on the Philae lander, which in fact consists of 3 experiments. Can you give us some details?
Yeah, that's correct. That's 3 different instruments with very different measurement techniques, but they still have a common goal to analyze cometary surface layer, the mechanical, physical properties, as well to study the cometary activity. And the principal ways of operating of these instruments, there's a Kasse instrument which checks vibration and can also send out signals into the comets. And we have the DIM experiment, which detects particles falling on its sensor on the cometary surface, and the PP instrument, which analyzes the electromagnetic environment.
And did you have a chance to do any measurements already, or are you still waiting?
Oh, we had a lot of measurements during cruise phase. And even before landing on the, before starting the descent now in the PDCS phase in October. But of course we are in situ experiments which have to, usually have to contact with a subject of investigation. And so we do some measurements now during descent, and we received early the first data from our instrument when we were still connected to the orbiter. And we do some calibration measurements during descent for 2 instruments as well. We try to measure particles during descent that would help to link the information obtained later on the comet and to the orbiter dust particles instruments, as well the Kasse instrument will try to take the touchdown signal.
Okay, it sounds like the Sesame instrument, which I believe only weighs 1.5 kilograms, is not very big, really, is quite busy, and you, of course, will be very busy with it as well. Klaus Seidensticker from DLR in Köln, thank you very much. And we're moving now to the other side of Hermann Böhnhardt to speak with István Apati from the Scientific Institute of Hungary in Budapest, the co-PI of the ROMAP instrument, also the co-investigator of the Sesame instrument, which we just heard about. So first of all, welcome, István. The Hungarian government, I believe, has just recently filed the legislation to become a full member of the European Space Agency, but you've been part of this mission right from the beginning, right when the Iron Curtain lifted or fell, whichever way you look at it. How did you join?
We are developing electronics for charged particle devices since the 70s. And it was a big success for us, Haley mission. We had a plasma instrument there. And at that time, that was a Soviet spacecraft, already Western countries were switched in a little bit. So some components were produced by the Max Planck Institute at Katlenburg-Lindau. And after this big event for us, I became Max Planck stipendium from this Max Planck Institute. So I worked 4 years at Katlenburg-Lindau on the Phobos mission for energy spectrometer as well. It was very successful. We became very good friends with Dr. Helmut Rosenbauer, who was a director of the institute at that time, and later on a principal investigator of Philae, and he was who invited us, the Hungarian Institute, to participate in 2 experiments in the dust impact monitor as part of the Sesame, and charged particle spectrometer, which is a part of ROMAP. There are 2 instruments together, a magnetometer and our charged particle detector. All this in international cooperation. So Braunschweig University is responsible for the magnetometer. Max Planck Institute developed the sensor of the charged particle device. We developed in Hungary the high voltage control unit of this spectrometer. And there is the heart of ROMAP, the microprocessor control unit. It was developed by the Austrian Space Research Institute.
Yeah, István, just briefly at the very end, because you're the only person I speak to from Hungary in this mission. Is space science an issue in Hungary?
Yes, it was all the time for the last 40 years, and now as we became a member of ESA, it helps a lot to make more science and most of all space industry.
Okay. Yeah, brilliant. Well, thank you very much, István Apáti, Hermann Böhnhardt, and Klaus Seidensticker in Cologne right now at the Lander Control Center there. Thank you very much. And again, best of luck. Fingers crossed that everything is going according to plan and that you can do all your science from now on. Well, ladies and gentlemen, you're watching a live broadcast from the European Space Agency in Darmstadt, bringing to you what is about 4 hours from now, hopefully, the successful landing of Philae, the lander on board the Rosetta spacecraft, on the comet Churyumov-Gerasimenko. And a few meters from where I'm standing right now, there is a building called the PISA building, and there is a large group of people. We have pictures here right now, sitting. You see they're working very hard, very concentrated. I'm not sure yet how many years, but I said of them 80, maybe even 100 years of scientific experience is sitting in this room right now. Principal investigators of at least 10 instruments together with their co-PIs working on data that is coming in, and more data that is coming in very soon. And I'm sure they will share their findings with us as soon as they are ready. But in the meantime, I have 2 more gentlemen sharing the stage with me right now, which is good. I've got 1 microphone for each of you. And the gentlemen are Wlodek Kaufmann, a PI of the CONCERT experiment. We just heard a little bit about that before, from the Institut de Planétologie et d'Astrophysique de Grenoble. And Stefano Mottola, who is the Rollis investigator from the DLR in Berlin. Good to have you here.
Good to be here.
And Wlodek, I would like to start with you, because CONCERT, we heard it, is already switched on during the descent. What will it measure?
CONCERT is the instrument, in fact, is the bistatic radar, measuring between lander and orbiter. It was built to do the tomography of the comet. Today, we are measuring the distance between spacecraft and Philae during the descent. And this will give us the information about if this distance corresponds to the nominal one. In this case, we'll be able to say that we are most probably on the good trajectory. At about 3 p.m.
Okay.
Coming to here, and we probably will be able 1 hour later to give some inputs concerning.
Okay, so the next time when we start our live program, we may already have that information thanks to CONCERT.
I hope so. Yeah.
We hope so. Now, as far as I understand, CONCERT is the only instrument that is both on the orbiter and on the lander. Why is that?
The reason is that we wanted to have a radar able to penetrate inside the comet. To build the true radar was not possible because the mass and power consumption was too big. As it was a really new experiment, nobody will accept too heavy instrument. It is why we had to build a small instrument on the lander and orbiter and use the transmission of radio waves through the comet. Mm-hmm. And this will give us the possibility to understand and to measure the interior of the comet.
So if you sort of almost do an X-ray of this comet in a way, what do we expect to find? We have an image here. Is this sort of the kind of picture we can look forward to?
Okay, this is our imagination today, but in fact there are many models concerning interior of the comet, and nobody knows how the comet is built up. Which means that I believe that we'll be able at least to say if there are the differences between head and body of the duck. If you have some kind of layer structures inside, we'll be able to detect. If you have enough measurements, which means that some number of orbits during the next 3 months, we'll be able probably build the 3D images of the interior.
Mm-hmm. A 3D image, wow.
Yeah, this is the ideal. And of course, it will depend on how lander is, on the energy of the lander, essentially. This is the case, of course.
Some 70 hours of battery, as far as I know, so it has to happen in that time.
This battery will be rechargeable, and every 3 cometary days we'll have the new, let's say, almost new batteries. And we hope that we'll be able to operate during at least end of February, I hope so.
Yeah, well, we all do. Stefano Motola, your instrument is called ROLIS, and we heard it's switched on during the descent phase because it is the camera at the bottom of the lander. That's very interesting, looking downward. It's taking images, so when will we see the first ones?
Yeah, we will be acquiring images. We will be acquiring images during the descent. The first images will start at a distance of about 3 kilometers above the surface, and we hope to get those images around 6 p.m. Central European time. The rest of the images during the lower phases of descent will probably arrive around 8 p.m.
Mm-hmm. Now, while we're, of course, all very eager to see those pictures taken by ROLIS, this is not the scientific purpose for this camera to just take pictures during the landing. There's another purpose to it as well, but how does it differ from other cameras? Because ROLIS isn't the only camera.
Right. A ROLIS camera will provide a very high resolution. I mean, the resolution will ever increase during the descent. The last images will provide a resolution of about 1 centimeter per pixel, which is higher than the resolution we can get from the orbiter. And after landing, we will have a few tenths of a millimeter resolution. So this is a very high resolution that will enable us to see a different kind of phenomena. So, for example, at the moment, we do see that the comet displays activity. We see water ice sublimating and producing water vapor. But we didn't see clearly any exposed ice on the surface. So we don't know whether, for example, the ice is hidden underneath a layer of dust, or we don't know whether there are patches, but they are smaller than the resolution of the orbiter cameras, and the ice is intimately mixed with the dust. So by having a high resolution, we hope to see whether really we see small patches of dust and ice mixed together, or whether we see features where the gas is coming out from, like pores or cracks on the surface. So this will enable us to understand the processes that are at work now that produce the sublimation of ice.
And all that despite the fact that you're measuring during the night. For an ordinary person, that's a bit weird, thinking of using a camera when it's pitch black.
Right. During the descent, we will be observing during the day, but after the descent on the on-comet phase, we will be observing during the night. We have a small flashlight with us, an illuminator device that has different colors. 4 colors in red, green, blue, and infrared. Those colors are diagnostic for the composition of the comet. So we will be able to do color composites that are diagnostic for what materials are on the comet.
Okay. Stefano Motola and Włodek Kaufmann. Let's all keep our fingers crossed so that both your instruments, ROLIS and concert can really get down to business and bring lots of images and lots of data. Thank you very much for speaking to us.
Thank you. Okay, thank you.
Thank you. And talking of images, we expect the very first images taken during the descent anytime after 1:40 p.m. local time, that is 12:40 UTC. These images will be shot by the Shiva camera on board of the orbiter, and of course, as soon as we have them, we will go live on air and share these images with you. In the meantime, I would like to take one last look at our Twitter input, because I was just informed that the hashtag Comet Landing tops all the Twitter input right now. So We haven't exaggerated. People around the world, millions of people around the world, are participating in this event today, all hopefully keeping their fingers crossed. This does not look like Twitter to me right now. Wanted to share with you some of the tweets we got. But it is the Twitter statistics. It just shows you how much I know about Twitter. And there we see when it peaked, presumably, because there is no timing there, all the people who know about it more than I do, that's probably during the separation moment, but people are obviously participating, watching, and then eager to share their thoughts, their emotions, and their good wishes. Please continue to do so. We need all the support we can have. 700 tweets a minute, I think that's not bad. So let's hope that all this means that this is going to be a success today. We will take a much-needed short break for lunch right now, but of course, as always, our cameras will stay put in the main control room so that you don't miss a thing. If you want to keep watching, we'll be back again with our live program here on the stage and all the major players at 1500 Central European Time or 1400 UTC for our live coverage of then, hopefully, the landing of the Philae probe on the comet Churyumov-Gerasimenko. Until then, don't stop crossing your fingers. See you soon.
tu peux pas te voir tout en regardant la caméra. Ah mais voilà, ok, d'accord. Ouais, j'ai changé, hein. C'est mieux quand c'est mono.
Pass auf, wir würden hier stehen, hier würde der Interviewpartner stehen, wenn wir wüssten, wer das ist. Sich noch keiner gemeldet. Der Herr, von dem ich dachte, dass es ist es wahrscheinlich nicht, weil er sagte gerade, er hat eigentlich hier nichts zu tun so.
Yes, no, I don't hear. I hear you, but I don't hear anybody else in Pisa Road.
Hi, Dominic. Here is another Dominic.
I hear somebody, but very
Hi,
far.
Hi, Dominic in the event room. Here's the Dominic of the Pisa room.
Okay, so this is Dominic in Pisa, and this is Dominic in the conference room. Okay,
Yeah.
so I hear you. Fantastic.
Hi.
Okay, that's cool. Thank you.
Die Kommando ist unheimlich laut,
Aufschön.
Freunde. Das geht nicht lang gut. Nur die Kommando ist ziemlich laut. Im Vergleich jetzt zu meinem Gesprächspartner war die Kommando ziemlich laut. Sonst geht's. Aber du hast vielleicht doch, ja, vielleicht hast du auch näher reingesprochen, weil jetzt geht's wieder. Also mach dir keinen Kopf. Ja, weißt ja, die Toningenieure unter sich haben auch immer empfindlichere Ohren. Ja, aber nur bei 9 Kilo, nur bei 1 Kilohertz bei minus 9 dB. Da würde ich drauf wetten, dass ich mittlerweile auch eine kleine Wanne drin habe. Das könnte schon sein.
Okay, good. PISA, ça veut dire quoi? Ok, support area, c'était le support area qui me manquait. Ouais. Of course, I mean, well, you can reassure them. I told them that we will be in the waiting mode. Yeah.
Oui, tout à fait. Je suis un tout petit peu perdu.
Un peu moins de 10 minutes.
Sinon, c'est normal qu'on n'ait pas du tout ici. Les séparations. Non, non. Dans la pièce, on a reçu.
Bon, il y a une image. Hein.
Oui, oui, on peut passer. Je crois qu'ils l'ont mis en process automatique. Je peux regarder les chinois parce que je trouve les charges. Tu as regardé sur le son, c'est ça?
Les dates.
Alejandro.
Oui.
C'est Wally pour toi.
laisse un paquet. Ah ouais, non, on va aussi parler. Confirme. Oui, on confirme. Et ça va être traité. Là, on risque de voir ce qu'on va déjà y avoir l'image. Ouais, mais... Si vous voulez, vous l'envoyez par email à ce moment-là. Non, non.
Be able to show something and to speak. But it's not so spectacular. Do you hear me? Now?
Guten Abend, good afternoon, bonjour. We jumped into the transmission because we've got some very good news. So let's not wait and go right away to Toulouse, to the song, and with the chef de projet from CNES, CNES project manager, Philippe Godon. So what's up? What's new, Philippe?
What's new? We have started to receive the science data. And so particularly the first images after the separation. So an explanation, a detailed explanation will be done after by Jean-Pierre, responsible of Shiva and PI of this instrument. But we can see that at least Philae was separated from the orbiter. So it's very, very good news.
Yeah,
and
good news.
It proves also that all is working well on board because the battery was working nicely. The TXRX, the system of communication between the lander and the orbiter has worked very well. And it seems that all data have arrived concerning the first images from Shiva. And moreover, we have received also SESAM data, MOPUS data, and roadmap data. So we have, for the moment, all the data we were waiting for.
That's fantastic. So that means that everything is going as planned. We are receiving information. So let's jump into now the PI, the PISA, the Principal Investigator Support Area, where Jean-Pierre Bring, the Philae lead scientist, and the SIVA responsible, will explain to us what we are currently seeing. I guess he's got the similar data than you have, but maybe in a better, in a more accurate way. Jean-Pierre, can you hear me? Well, probably Jean-Pierre is still processing and working with his team. You know, they have got this room, which is not far away from the control room, and they are receiving the data. The science, as we just heard from Philippe Godin, is coming. You know, everything is coming as expected. We know that there is a bit of a margin, so this is, of course, you know, we are like 400 kilometers away from them, so it takes time. But so far, we are receiving some data, some science, and we also got this selfie, this image, and we hope that Jean-Pierre can give us some more explanation later on. I just make another try toward the PISA room. Jean-Pierre, are you able to tell us more about this thing, this nice information that Philippe just told us? Well, I think so. You know, this is the game. I mean, we just stay live. If there is anything more, and if Jean-Pierre can come soon to tell us more, we will also, of course, jump into this transmission. So thanks for following it. And you've got this rendezvous at 3 o'clock at 15 CET or 4 GMT with the rest of the program. And we've got a lot more to show you. See you.
Enough. Walk with me. Perhaps we should find you something a little less challenging.
I don't understand. I planned everything. Let me do it again.
Once upon a time.
Really?
This is a good one, I promise. What is the key to life on Earth?
Water.
Water. For a long time, the origins of water, and indeed life on our home planet, remained an absolute mystery. So we began searching for answers beyond Earth. Where could all this water have come from? In time, we turned to comets. 1 trillion celestial balls of ice, dust, complex molecules left over from the birth of our solar system. Once thought of as messengers of doom and destruction, and yet so enchanting that we were to catch one. A staggeringly ambitious plan.
Are you talking about the Rosetta mission?
Throw me the probe. We harnessed whole planets and their gravity to chase down the comet. So many things could have gone wrong. A failure at launch, an error in the calculations, collisions, so many unknowns. With the technology we had back then, we may as well have been shooting from a slingshot. And tell me, what was it all for?
Knowledge.
Yes, but we also wanted to show what was possible.
I know all this from the archives. There were bigger missions after.
Yes, it was the first one to catch a comet. Ambition. Stubbornness. Nothing has changed. We fall, we pick ourselves up again, and we adapt. I was watching you earlier. You actually did everything right. I destroyed your rock. I needed to see how you would react. You're ready. Reset. Nicely done. Let's begin.
Ladies and gentlemen, distinguished guests, welcome to the culmination of an ambitious project. And as we've just seen, ambition, this drive to reach for the stars, well, this is not only something that drives science. Without this need to reach for the stars, to be ambitious, mankind would not even have left the caves, let alone find all the knowledge that we have found up until today. So with this, a very warm welcome to the European Space Operations Center here in Darmstadt. We have gathered here this afternoon in order to see ambitious history in the making. My name is Monica Jones, and I can't tell you how delighted I am and how privileged I feel to be here with all of you this afternoon in order to witness one of the most adventurous and exciting scientific adventures of our time. And of course, in order to guide you through the program as well this afternoon, and part of that is to announce the speakers. And I know that right now, most of those who will come up on this stage will be perhaps a little bit more nervous than they are usually at these occasions. Now, the gentlemen that will come up on stage one after the other will be Thomas Reiter, head of ESA's Space Operations Center here in Darmstadt and the ESA Director of Human Space Flight and Operations. It will be Jean-Jacques Dordain, of course, the ESA Director General, and Roel Gattier, the Chairman of the Scientific Program Committee and Director of the Dutch Space Agency, SRON. And I would like to start with Thomas Reiter. The stage is yours.
Good afternoon, ladies and gentlemen, distinguished guests. Welcome to ESA Space Operations Center on a very, very special day, on a very special occasion. Today, I believe it's true to say we might all together experience another real first in the history of spaceflight. We are ready to wrest from this comet more remarkable secrets, to get some crucial answers to questions such as the origins of life on Earth. We have very nicely seen that in this beautiful animation. We are ready to make science fiction a science fact, and we are ready to continue on this daring journey. The stage has been set, and now the wait is almost over for Rosetta and Philae to land on a comet nucleus. Ladies and gentlemen, dear guests, it is really a great pleasure and an honor for me to see the world's leading comet chasers, space science experts, researchers, industry managers in this room, as well as political decision makers, partners from our member states. Today, I would like to greet in particular Jan Werner, head of the executive board of the German Aerospace Center DLR, Roberto Battiston, the president of the Italian Space Agency ASI, David Parker, chief executive of the UK Space Agency, Ole Norberg from Swedish National Space Board, Eric Becker, head of the Belgian Belspo organization, Daniel Neuschwanden, head of the Swiss Space Office, and our colleague Jim Green, NASA Science Director. Moreover, it's a pleasure for me to welcome Kari Till, who is head of the Finnish Tekes organization, Marius Ion Piso, CEO of the Romanian Space Agency, Roger Bonnet, a former ESA science director and one of the historic fathers of the Rosetta, and of course a famous person, Klim Churyumov, one of the co-discoverers of our notorious destination comet, one of the two. It's really a pleasure to have you here. From politics, we are very honored by the presence of Mr. Klaus-Peter Wilsch. He's the head of the German National Parliament. Then we have Pierre-Yves Le Bon, member of the French Assemblée Nationale, Jochen Patsch, the Lord Mayor of Darmstadt, and members of the Hessen Regional Parliament. I'm also glad to see here in the room Joël Barr from CNES, Alain Ratier from EUMETSAT, our neighbor, Mr. Jens Weidmann from the Bundesbank, members of the diplomatic corps and staff of the German Ministry of Economics and the German Chancellor's team, officials from many national ESA delegation, industry managers, also from our prime contractor Airbus Space and Defense, Michael Menking, and numerous journalists from around the world and many other passionate partners of ESA's space science endeavors. Later on, we will be joined by the Swiss Secretary of State, Mauro Dell'Ambrogio, co-chair of the ESA Ministerial Council that is coming up, and the Minister President Volker Bouvier from Hessen, ESOC's host region. Last but not least, ladies and gentlemen, I would like to salute all my ESA colleagues, starting by ESA DG Jean-Jacques Dordain, by ESA Science Director Alvaro Jimenez, and of course all other ESA directors and my dear operations colleagues working very hard right now, day and night, in the main control room in the next building very close. Ladies and gentlemen, dear partners and friends of ESA, Rosetta, a mission that began as a dream, but that after decades of planning, construction and a 10-year, 6.5 billion kilometer journey through the solar system, after decades of taking together all expertise available in Europe with our member states, has arrived at its destination last August, and since more than 3 months is producing an incredible, unprecedented amount of spectacular images and invaluable scientific data. Rosetta will continue its fantastic mission by accompanying first mission in the history of spaceflight, the nucleus of this comet 67P Churyumov-Gerasimenko, for at least the next 1.5 years on its journey around the sun. Today, Rosetta is set to carry out the riskiest, most intricate maneuver, the landing of Philae, the first probe ever to attempt a landing on a comet. Thanks to one of the best flight teams in the world, there is no ambitious exploration without serious risk-taking. It's almost like a Hollywood actor. Rosetta has almost become a name in every household. Rosetta, the leading character in one of the most unique, interesting, and intriguing movies of all times. Full of suspense, full of expectations, and all about knowledge. Just like the discovery of the Rosetta Stone, which initiated almost an explosion of research and understanding of the Egyptian society and led to the cracking of the code of hieroglyphs, this namesake mission will unlock the secrets of our universe. Its aim, of course, to unlock the secrets hidden within the icy treasure chest of a 4.6 billion years object, to study its makeup and its history, to search for clues as to our own origins. Now I would like to leave the floor to our Director General and other colleagues who will provide us with more details on this exciting and very challenging part of the Rosetta mission. But before I do that, I would like to express my deepest gratitude to all those, too many to mention one by name, from past and present, who have worked so extremely hard to make this mission happen. Thank you for your knowledge, your dedication, your passion, and your professionalism. Thanks for daring, thanks for taking the risk, and thanks for boldly going where no one has ever gone before. Thank you.
Thank you very much, Thomas. So, dear colleagues, dear friends, I shall not go through all the list of all the colleagues and friends who are there. Thomas has done that. So, when we are at ESOC together, we know that it's for something important. But when I see you today, I can feel that today it's more than important. I think that this is something for the history. Today we are trying to do what nobody else has done before, and has even tried or dared to do. And so far, so good. We had the evidence of the separation. We had even the image and the sound. And we know that the descent so far is as planned. And I think that Jean-Pierre Bibring should be here to show one of the evidence. If you have something to show, you are welcome, because it's more important than myself. So if you can come.
First of all, I would like to really to say on behalf of the entire Philae and Rosetta Science community here that, to get to a comet is really an amazing venture once in one's life. And I would never thank sufficiently, and we would never thank sufficiently who all does make that dream really a reality. And of course, ESA is amazingly efficient in this venture. Of course, many other agencies directly, like DLR, CNES, ASI, and many others contributed. But really, thanks to ESA, we make a pioneering things, which is very risky, but so exciting that we are, very anxious. So, as you know, what we did today was to make this separation a success, and in itself, it's already amazing. Then what we did is to, maybe I will see that, as soon as we were released, we take an image. It was exactly planned 50 seconds after the release, and it worked perfectly well. And we take an image that just arrived here. So it's really not processed, it's really as it is. And if I can show that up, I don't know who does that. It should come sometime. You will see. It's not a brilliant image in terms of the image quality yet. It's not processed. It's even worse than that because we have the sun just facing exactly as I have the light here. So we see, and so you see the orbiter there. You see the solar panel. So you see where we are on this picture here. We see the upper left part. The problem is that we have the sun in the window, if I can say so. So the sun is illuminating everything scattered light, which is not important. It demonstrates the quality of the image and the dynamics of the image. You also see that it's not really focused. It's focused, but the rotation of the lander, which is 12 rotations a minute, make that during the exposure time, which is 600 milliseconds, we have 5 pixels illuminated by each of them. So it's really good because it demonstrates the quality of the capability of our system. Of course, it's an in-between things. In between the time we were connected to the Rosetta orbiter, in which we were really, everything went from that, and now we're autonomous. This was taken entirely autonomously by our own resources, energy, and of course it has nothing to do with what we will do in 2 hours from now. When the same thing will be there, we won't see the orbiter anymore. We say bye-bye to him, better images, but it's really moving to be here and to say that. And normally by 2 hours from here, we'll be able to show you where we have landed and how we landed. We'll get 7 images on the ground, 6 for the panorama, 2 for stereoscopic views. If we are lucky enough, we will show you that immediately here, which will be around 7 o'clock tonight, maybe a little earlier, maybe a little later, depends on how things go. But for the moment, it's really more than we dreamt. It's really a huge success of ESA here and all the community which is behind. Thanks a lot.
So, merci Jean-Pierre. So, as you can see, we have separated, that it's for sure. And what we know is that the lander is in good shape, and even the landing gear have been deployed. So, meaning that Philae is ready, but we are not yet there. And we are not yet there because what we are trying to do, as I said, is very difficult. Even more difficult than expected. The shape, the surface of the comet are very different than what we were expecting, which is always a good surprise for the scientists, but a bad surprise for the pilots. But pushing the frontiers of the unknowns is always risky, as Thomas and Jean-Pierre already said, but the risks are the price to pay for making discoveries. And this is what the science program of ESA is doing every day. Discovering the universe, we have done that with Planck. And Planck has revealed the unknowns of the universe very close to the Big Bang. Discovering our galaxy, it's what we are doing with Gaia, who will measure the position of 1 billion of stars of our galaxy. And discovering the solar system, it's what Rosetta and Philae are doing. And it's even the solar system before the formation of the planets, which is certainly a very important part for understanding our origins. So we have rendezvous with our origins, meaning with our future. Because at the end, the only destination of all what we are doing is planet Earth. It's to understand planet Earth. So speaking of rendezvous and planet Earth, I am glad that Professor Churyumov could be with us today. So Professor, we are going to you, and you came to us, which is not bad because you have made several hundreds of kilometers to come to us, And we are making some billions of kilometers to come to you and to go to you. So I think that this is a fantastic rendezvous that we have together. So the scientific program of ESA is the backbone of all our activities at ESA for several reasons. First of all, the participation of all member states, which is a symbol of solidarity. And I am very glad to have most of the member states present today. Thank you very much. But it's also cooperation with individual member states and their space agencies. And for today, this is mostly for the instrument Philae, because Philae is a fantastic instrument of the Rosetta mission under the management of DLR with significant contribution of CNES and ASI. This is also cooperation with international partners, and I am glad to see that we have representatives from NASA because we are together on board Rosetta. This is also the science program is delivering a fantastic new range of new technologies. Just to say, on Rosetta, we had to invent new technology for the solar panels because Rosetta is the only spacecraft going to so-called regions without radioisotopic thermal generator, which is one of the many particularities of Rosetta. But also the science program is driven by scientists. They provide the ideas, and they even define the priorities. And this is implemented by European industry. A lot of companies from almost all ESA member states under, for today, the prime contractorship of Airbus. So when you mix the best scientists, which have dreams, and the best engineers, which can materialize the dreams into reality, you have the best science missions of the world. This is ESA. But ESA is also, and I would like to end by that, ESA is also the best staff of the world. I am at ESA since long, as you know, unfortunately. The fact that you know is unfortunate. Not that I am long at ESA. But I am still amazed every day by the expertise and the dedication of ESA staff. Rosetta is 20 years of activities for a lot of staff from industry, as I said, national agencies, scientific and research, but also ESA, with just a short break for the hibernation of Rosetta, so they could relax for 30 months. But apart from that, they are working every day, every night, as last night, to manage the risks, because this is what they are doing. It's to manage the risks, all of them. But since we are at ESOC, I would like to have a special word for the best drivers of the world. Just imagine that the accuracy of the trajectory of Rosetta was 30 millimeters, meaning that the last delta V for finalizing the maneuver was only a few millimeters per second. And that is fantastic, because you have to understand that a velocity of 1 centimeter per second perpendicular to the trajectory is 250 meters at the surface of Rosetta. So the accuracy of delivering Philae was crucial, and they did it. They did it while they have to adapt the operations almost continuously, because the comet is a living comet with outgassing, meaning that they have to adapt their operations almost every day with 30 minutes of delay for the information coming to them. So if that is not expertise, I would like to know what is expertise. So I would like to thank my colleagues of ESOC for all what they are doing. But okay, I would like to recall that we are not at the end. I am just knocking at wood. So you have still 2 hours to live. So live every minute of these 2 hours, because I am sure that this is the only minutes that you live, that you have a chance to live like that. So enjoy. Thank you very much.
Yes, ladies and gentlemen, today is indeed, it's all about ambition. And if you realize that the whole idea of a mission like Rosetta originated more than 30 years ago, and this idea, it could be realized because of an ambition. And it was an ambition set by European ministers responsible for space science 30 years ago, in 1984. And they expressed as a very clear ambition that Europe should be among the main leaders in the world in space science. It should become a world leader. And they agreed to a vision being worked out by the scientists. But they also agreed to a budget increase for the science program of ESA to fulfill this vision. And as many of you will know, it has already been mentioned, this was the basis of the very famous Horizon 2000 concept, the Horizon 2000 program. Still, this program inspires the current space program of ESA. In fact, you can say that the current space program, the Cosmic Vision program, rests on the original ideas of the Horizon 2000 program. And this program, it consisted of 4 very large breakthrough science missions, the so-called flagship missions or cornerstones missions, so to say. And Rosetta was one of these. It also consisted of a number of medium-sized missions and smaller sized missions. And all together, they constituted a program that could address a wide variety of science themes and also could count on the support of the scientists all over Europe. This Horizon 2000 program has been very successful, and in fact it still is, because Rosetta is still a part of this original program. If you just think of all the successes of the planetary missions performed in the past, like the Venus Express, the Mars Express, but also if you think of the Huygens lander on Saturn's moon Titan, also the solar missions, and of course the breakthrough scientific missions studying the universe at various wavelengths. The infrared with the recent Herschel mission. In the X-ray with the gxmLWC mission, which is still operating very, very well, already for 15 years now. And then last, but certainly not least, but indeed last from this program, but not least, the Rosetta mission. And if you add it all up, all these missions are an enormous success. All these missions succeeded and brought at least what was efficient in the beginning, and many times even more. And Rosetta, of course, is already a success, and if this landing this afternoon will be a success as well, that only will add to that. So the Horizon 2000 program and the successors of that program within ESA, the Horizon 2000 Plus program and the Cosmic Vision program, this really has put Europe at the front line of space research. And this is all thanks to an expression of a European ambition. And of course, thanks to political willingness to invest in breakthrough basic science missions. And also to be prepared to take risks with missions that are really, technologically speaking, at the edge of what you can expect. And Rosetta, and I want to stress that, is really the best example of that. Thank you very much.
Thank you very much, gentlemen. Just to bring you up to date, in about an hour and 10 minutes, starting from 1540 UTC or 1640 Central European Time, the moment will come when we will witness the landing of the first European space probe on a comet which is 500 million kilometers away from here, deep, deep in space. And you heard it before, but it cannot be said often enough. This is something that has never, ever been done before. And interesting enough, this mission has caught people's imaginations around the world. It has certainly caught their interest. And you will have noticed when you arrived here, there's a huge media lineup, hundreds of TV vans, journalists from all over the world covering this story. We have a lot of journalists here in the room. At this point, thank you very much that you do cover this story, because I think it is a story that is worth covering. We are being broadcast live in hundreds of scientific institutes, science centers, planetariums, universities, even schools. The movers and shakers of the world, even those that are not here, are watching us. EU Commission members watch us in Brussels. Parliamentarians of all the ESA member states are watching us. And of course, there are literally thousands of local venues where people gather in order to watch and witness history in the making. And if they don't watch it on TV, then they may watch it online and follow it on Twitter, because we do also inform everyone on Twitter, and we receive lots of comments. There was huge traffic 2 hours ago. We were top of the list of the Twitter traffic. Hashtag, by the way, is Comet Landing. What else? So the interest is huge. And as we're approaching really the culmination of this great adventure, if you haven't watched everything of our 24-hour broadcast, and I could not blame you if you sometimes had to do something else, then why don't we give you a recap, certainly of the highlights of what's been achieved today. Let's take a look.
Great.
Yes.
Yes.
Time to separate. Our separate was nice meeting you.
Released or relieved. So we were together for 10 years. It's time to separate, and we successfully separated now.
Yes, yes, yes. We're gonna, yeah, this is the one. Yes, still alive. That's the one. For the workstations, receive under That's the one. Yes.
The signal from Rosetta was acquired earlier on, and now Rosetta has confirmed that Rosetta is receiving signal from the lander. We can see the telemetry from the lander on our displays. We have an end-to-end link established. That's exactly what we wanted.
So, just to give you the wrap again, we had since last night 4 go situation. One was very critical in the middle of the night. We had a successful separation of the lander from the orbiter, and we also then received both signals. So everything is going well so far, but as you could tell by these images, it's quite nerve-wracking even for the pros. And so let's go over again to the pros, because their job isn't over yet. We've just seen Andrea Accomazzo there together with Stefan Ulametz, the flight director, and the Philae lander manager. And I think they should be standing by in the main control room now to give us, here he is, Andrea Accomazzo. Oh, I can see that you've had some sleepless nights there, Andrea. Tell me.
Yeah, I didn't sleep very long last night. But once in your life, you can do it. It's a good reason today.
But exactly, it's worth it. We're about an hour before landing. Do give us a short update.
Well, we keep receiving telemetry both from the lander and from Rosetta, of course. We have just done a station handover. We switched the telemetry reception and the telecommands from our station in Australia to the one in Argentina. And we have just received the confirmation as well from the flight dynamics team that the lander appears to be properly positioned in the OSIRIS images. So we see the lander going down on the right track.
That's fantastic news,
Indeed,
Andrea.
Indeed.
That makes us feel really good at this moment. Yes, people applaud you here.
Yeah, thanks a lot.
And just to give us this last little bit of comfort, is there anything you can do now to influence things happening?
Well, no, absolutely not. I think we had many things to do in the last 10 or 20 years, in the last months, in the last weeks, in the last night as well. We have done all what we could to have this mission successful. I think now it's up to the lander. As I said several times as well, we need to be a bit lucky as well. We perfectly know that we cannot control the touchdown conditions. It's already a major success to have been able to come to this point and to follow the lander throughout the descent, and now we have to land successfully. It's the next step.
Okay, Andrea, you said it's down to the lander, so I think I should now talk to the lander manager, Stefan Ulametz, who is there in the main control room with you. Andrea, best of luck.
Yeah,
We'll keep an eye on you in an hour from now. Thank you for now.
Thanks a lot. Stefan is here.
Okay, there he is, Stefan. Stefan,
Don't have anything.
you can't hear me.
So you can hear me, I can't hear you.
Okay. There comes the earpiece. Doesn't have to look nice.
Hello.
Does it work? You can hear us?
I can hear you, yes.
Fantastic. Stefan, I believe you have your eyes glued onto the screen because you receive a lot of telemetry data. What does it tell you? Where are we now?
Well, it's just fantastic. You see in the background here, we are still 1 hour, 25 minutes from reception of the touchdown signal here. Of course, there is some uncertainty. There is a touchdown window. But also what we get right now is already really fantastic. So also from the instruments, we have science data. You've seen the Shiva image. We have data from the other instruments as well. We could measure that the lander is currently rotating. Takes about 9 minutes to rotate once around its axis, which is interesting, and no problem for the landing itself. Everything looks really, really good, and of course we are curious now to find out what's happening on the comet. It will happen in less than 1 hour from now.
Less than an hour from now, but you also touched on something. You said there's a bit of uncertainty because we said there is this big window of possibility that the landing could start as from 1640 Central European time all the way down to 1720. Right now we think it could be at 2 minutes past 5 p.m. or 2 minutes past 4 p.m. UTC in the afternoon. Where is this uncertainty coming from?
Well, there is not only a landing ellipse on the area of the comet, it's an ellipsoid if you want, so there is also an uncertainty in the exact touchdown time. And our team in LCC at DLR in Cologne will then analyze the data. Once we get a touchdown signal, they will confirm that the harpoons are anchored, and then we really know that we are on the ground and the system is working and Philae is talking to us, which is the most important thing after the landing.
Okay, Stefan, I will let you go now because I know that you're eager to keep an eye on your screens, and everyone here in the room and around the world is keeping their fingers crossed. We'll be back with you later.
And that's very much appreciated. Thank you.
Okay.
Bye-bye.
Well, ladies and gentlemen, we keep talking about a comet that we're about to land on, which has, for many of us, a quite complicated name, Churyumov-Gerasimenko. I, for one, was struggling with this for a long time. I can say it now without looking onto a piece of paper, but nevertheless. And maybe you were wondering, where are these names coming from? Well, there were two scientists who named the comet, basically, after they discovered it. And one of them is standing right next to me, Klim Ivanovich Churyumov. So you are the first part of that comet in name. You're one of the discoverers. It's really good to have you here with us today. How do you feel today, knowing that we come and land on your comet?
Oh, thank you. Dear colleagues and friends, how are you? This day is a great day in cometary science and general science, and also in history of human civilization. This comet now all saw its nucleus, and as Rosetta made maneuver, and it is, I think, it is triumph celestial mechanics. It is unique, non-precedent experiment in the history science. I discovered the comet 45 years ago. It was so. In 1969, Kiev University sent expedition, astronomical expedition to Almaty, and we, together with Svetlana Gerasimenko, I was leading of expedition. And Svetlana Gerasimenko was a postgraduate student. Our teacher was a famous astronomer, Professor Siksviatsky, and UNESCO 2005 years. It was Siksviatsky years. Siksviatsky, my and Svetlana Gerasimenko teacher. When we went to Almaty, we, with help highlight telescope, meniscus Maksutov telescope, we observed several comets which belonging to Jupiter family. It is comet Phi, Honda Mrgospaidushakova, and other. And comet Sola. We observed this comet, and when we observed comet Sola, we, with help of photographic way, we photographed the comet Sola and made several plates. And on 5 planets where was comet Sola, we found out new object. But
so it was by chance.
Yeah, but five position, exact position, equatorial coordinates, we sent to Central Bureau of Astronomical to Professor Marsden. 5 position, it is very, it is enough to determine the exact orbit. And the comet was found out through 1 month after our observation. And Marsden confirmed that it's a new comet, as we to discover comet was named Churyumov-Gerasimenko. And in catalog, astronomical catalog, it has number 67P.
67P.
Yes.
That's easier for everyone, but we don't make it easy for us, Mr. Churyumov. We will talk to the counterpart, Mrs. Gerasimenko, in just a moment. But I have one more question, because you're so experienced and there is a comet named after you. Can you tell us, please, why do you think that space science, astronomy, is important to society?
Yes, astronomy, it is most important science for human civilization, because astronomy give calendar, time, exact orientation in cosmos, in space, and in ocean. and in future, when not enough нефть, как бы сказать это сейчас, oil, water, not enough.
When we run out of resources.
Not enough, this matter, this substance, and we will use space objects, asteroid, comets, moon, and made and give these minerals, these substances from celestial, from space objects, and comet will be will play a very important role that to save humanity from not enough mineral ore.
So eventually it could one day save humanity and human life on Earth. So Mr. Klim Churyomov, thank you so much for being here today. And we hope we will land on your comet. We do. Thank you very much. Be careful. So ladies and gentlemen, we now kept a lady waiting, of course, because the second name is Mrs. Svetlana Ivanova Gerasimenko, and she will join us now, not here on stage, but she's in the Lander Control Center in Cologne, standing by already. There she is with her interpreter. Welcome, Mrs. Gerasimenko. It's a great pleasure, great honor to have you here as well. So you're the co-discoverer of the comet Churyomov-Gerasimenko, and you discovered it 45 years ago. We were just told by Mr. Churyomov. Perhaps you can tell us a bit how you recall that moment of discovery, and if you knew at the time that you actually discovered something totally new.
Вы нашли комету, и какое у вас было чувство, и в это время вы знали, если это был новый объект или нет? Какие были у вас чувства, когда вы эту комету открыли?
Ну, вообще растерялись. Сразу растерялись, а потом обрадовались.
So at first we didn't know what to do. We're a little bit startled and taken aback at our discovery, but then of course straight away after that we're extremely happy.
Very concise and succinct answer. Thank you very much for this one. Let me get as succinct as well. Has this discovery changed your life or your career or both?
Как это открытие поменяло вашу жизнь или вашу карьеру или оба?
Нет, это открытие не поменяло ни мою жизнь, ни мою карьеру, потому что кометами я начала заниматься до того, как стала их наблюдать.
This hasn't really changed my life or my career so much because I've always been interested in comets, and as such, that's why I went into this field of study in the first place.
Then I have one last question. Now, since August, we know what this comet looks like. Do you like it?
С августа мы знаем форму кометы вашей. Вопрос такой, вам форма эта нравится или нет?
Ой, мне очень форма нравится. Напоминает женский сапожок.
I like the form very, very much. It reminds me of a boot.
A root. Okay.
I like it very much, yes.
If she likes it, whatever it reminds her of, that's good enough for me. Thank you, Mrs. Gerasimenko, and thank you for discovering this comet together with your colleague in crime, Mr. Churyomov.
Спасибо. Thank you very much. Thank you.
Well, ladies and gentlemen, it is quite fascinating how interesting such a piece of rock and of ice and dust can be, millions, billions kilometers in space as it's traveling there. And I just was informed that we have another brand new image, and Holger Sirks, the PI of the Osiris camera on board Rosetta, is here to present it. Holger, tell us and show us.
Yes, so this is a very great moment. So we have the first images taken by the orbiter, by Osiris, coming down straight these minutes, and we are a bit late as usual. So we have 3 images straight out here. This is the wide-angle view, so don't be frustrated. This is the wide angle. It's 12 by 12 degrees. That's the lander on there, and there is its activity. We see strikes as well. So now we zoom in to the full capacity of the narrow-angle camera. Here you go. And the number 3, the zoom in, the number 3. Wow.
And it's got its antennas and the eyes that we know.
The gear is deployed, the antennas are deployed, nothing more to say.
It's fantastic. Thank you so much for sharing this with us at this moment. Thank you very much, Holger Sachs. All right, and seeing these pictures, I'm sure that this gentleman here, who I will give the microphone to, ESA's Director of Science, Program and Exploration, your heart must be lifted when you see things like that?
Certainly, I mean, really exciting, yes.
So we've been talking already about, the introduction film was called Ambition. It was mentioned several times that this is been the first time we attempted. It is risky. We don't quite know if it works or not. But we also heard that whatever happens, this is already a success. Would you subscribe to that?
Certainly. I think it's a great success. Rosetta and Philae, the mission is a great success. We got a lot of science already. We have around 90 scientific papers ready to be delivered. We have more science to come in the coming weeks and months. And we have something that we should not forget. We have now 1 year ahead of us where we are going to live with this comet. It has never been done, being for so long with a comet. And we will see how the outgassing develop, how it move, getting closer to the sun, and then build up the tail, the coma, things that we are used to relate a comet with. We will see how it all develops in this mission with Rosetta. But of course, we are here today also for the landing, and this is very important. I used to say it's the cherry on the cake. We have already the cake, but it's all very good to have the cherry, and it's a fantastic and exciting cherry that we are going to enjoy.
Absolutely, and I will not have my cake without the cherry. Science, from the very beginning, of course, for the European Space Agency is one of the pillars of the ESA's mandate. Rosetta mission is a highlight, certainly. But how would you recall the 5 decades, 50 years of European cooperation in space from a science point of view?
Well, science, it has been said, is the backbone of the agency, and science has been developing with ESA, with the scientific community, with industry, all together. And in the years, we first started by putting Europe in the map. Now we are putting Europe at the lead. So we are really increasing the activities in space science. The successes are one after the other. And we are really enthusiastic about this, what we are doing here. We can recall the mission Giotto, which was our first mission to a comet in 1986, and where it was a flyby. But there we were so enchanted, so fascinated with comet, that we had to dream and we had to make something better, like getting there to the comet, and that is what we are doing today. So our dreams are becoming true. But we also have done other things, like in 2005, landing in Titan with Huygens. This is also fantastic. It's exploring a new world, finding out something we didn't know how it was, and so close to us, Titan, in appearance, but so different in chemical composition. Also Mars Express, finding out the distribution of water in Mars, or moving to other areas like Planck, where we can see the very first life of the universe, and seeing how the Big Bang actually fit our understanding of the evolution of the universe. So there are so many things that we are so happy with it.
So many highlights. Today, of course, all eyes are on Rosetta and especially Philae, the lander. But I mean, when you look at, I almost want to call it hype, because really millions around the world are watching and really interested. Is there the potential of, in future, having anything close to this breathtaking adventure again?
Well, of course, we are delighted with Rosetta. It's an ambitious, a great mission, but it's only one among others. We have more missions, and we have, for example, now Gaia in orbit is going to make a three-dimensional map of the whole galaxy. We are going to go very soon with a mission to test the technology to measure gravitational waves. It's called LISA Pathfinder. We're going to go to an unknown planet, a very unknown, the most unknown of the terrestrial planets, which is Mercury. We have a mission called Bepi Colombo that will go there and measure that with unprecedented accuracy and better knowledge. And we have other missions like JUICE that we are now preparing. Is a mission to actually orbit one of the icy moons of Jupiter. So one of these moons will be orbited and will be analyzed in detail, in addition to flybys of other satellites of Jupiter, like Europa, that of course we are interested in. So there are many things coming, and in the area, of course, of astronomy also we have one that will come. It will be very, very impressive for science, which is Euclid, where we will measure, we will try to understand dark matter and dark energy, and what is the relevance of these components in the evolution of the universe. So big questions, and we have to give, for this big question, of course, answers related good space technology.
I have one last question, Mr. Jimenez, and that is, we've heard about the cooperation. A project like the Rosetta mission is not possible with one operation team alone. There are so many involved across nations. It is a nation-building undertaking, if you like. And when we look at Europe right now, do you think that a mission like Rosetta could help Europe, especially also the youth of Europe, to find a European spirit?
Well, of course, I think it is. I mean, Rosetta is a mission inspiring. I think it is a representation of the real spirit of Europe and the ambitions of Europe, and also the history, the culture of Europe as explorers. And this, I think, is materialized in a mission like this. This is a mission that we cannot do in Europe individually, in national level. We have to do it together, and it's a proof of what we can achieve when we work together in Europe. And this is also important for... And this is, I think, also important for inspiration for next generation. Younger people will see this and will see, well, I want to do this when I get my degree and what I got. This is attracting the best brains into doing science and technology. That is what we need in Europe. So it's where we have to put our effort. And I think if this is just helping, I mean, a mission like this, in inspiring next generation, and of course inspiring the countries and all member states in Europe, that I think is already worth the mission.
Absolutely. Alvaro Jimenez, ESA's Director of Science Programs and Exploration. Thank you so much. Well, ladies and gentlemen, we are, if my watch is correct, roughly 40 minutes from the first possibility of the landing taking place. Let's just remind ourselves that the Philae lander was separated from orbit about 6 hours ago and is currently just a few kilometers above the surface of the comet. That in itself is already quite exciting, and I look forward to the pictures when we get those in. But I would like to speak now to the lady who was the very last one to touch the lander before its great journey, and we cross over now to the Lander Control Center, where Ulrike Ragnit is standing by. and she is the Lander Architect and Integration Lead of the Philae Lander. Ulrike, can you hear us already?
Yes, I can hear you perfectly.
Wonderful, wonderful, Ulrike. So I just mentioned you were the very last person to both see and touch the lander before that hatch was closed on the rocket and Rosetta launched into space. Do tell us a bit, what was that like?
Oh, this was a very interesting and challenging experience. This was at the time when the orbiter and the lander was already on the rocket, so on the launcher, and the fairing was already integrated. So it was from the anchoring system. So I was moved into the fairing, was fixed on a platform, a so-called diving board, and I had to lie on my back on this diving board. We have to use two of the hatches from the fairing. So one hatch was just for myself and the diving board, and the second hatch was to pass tools inside the fairing, so that I got from my colleagues from outside.
We see a picture of you there where
God.
we see your feet at the bottom as well. So it must have been quite an experience.
Yes. Yes, it was quite an experience, and it was very narrow because the hatch has a diameter of about 60 centimeters.
We see a picture of you there where
God.
we see your feet at the bottom as well. So it must have been quite an experience.
Yes, it was quite an experience, and it was very narrow because the hatch has a diameter of about 60. And the units are quite close to each other. Some units just have 10 millimeters between each other.
Now, you know that Philae, the lander, by the time you said goodbye to it, and you did not want to share with us what you wanted to say, but that's okay. It wasn't called Philae then. That name came later. And Philae stands for the island of time on the river Nile. I personally think that's a very poetic name. But do you think that Philae, the island of time, will make it today?
Oh, I'm sure about it.
I wanted to hear that.
Absolutely No, I'm absolutely honest. I'm sure that it will do it. The comet has to be friendly to us, and we need a bit of luck, yes, for sure. But I'm not concerned about the hardware or the performance of the lander at all. And anyhow, the Rosetta already right now is such a great success. And if we are even able to land Philae on the comet surface and make one picture or God knows what from the first science sequence, I think this is an absolutely great success. I think it was said before already plenty of times, this is the first mission which had a rendezvous, never done before, and this is the first mission which is trying to land on a comet surface. I think this is success for the science world already enormous.
Absolutely. And it's so beautiful to see the science world pulled together so closely as we have done over the last 18 hours or so since we have been on air. So Ulrike Ragnitz, it was very good to speak to you, and fingers crossed, I hope everything is going well today.
Yes, I hope that as well. It will do.
Well, ladies and gentlemen, apart from the three gentlemen, they're already there on stage, and I have to apologize. You'll have to wait just a wee bit longer because I was told that we do have some tweets in that we would like to share with you. They should pop up on the screen, and I should start at the bottom. So there is a Neil deGrasse Tyson saying, "Yep, we're soft landing on a comet today. Normally, my we means at NASA, but in this case, it's at ESA, the European Space Agency." Thank you very much. Wow, at ESA, Rosetta tweets farewell photo from the space. Well, obviously, that was a beautiful picture. The Osiris image is a beaut. Oh my, coming online any minute. Yeah, well, we're counting the minutes too. Go Philae, good luck for touchdown. ESA, Rosetta, myself and the world are with you. Comet Landing, our hashtag, of course, and I presume that there's a nice picture from Alexander Gerst. Well, thank you very much for this. Guy Boyd, fantastic image of Philae on course to 67P. And Justin, we are taking pictures of a lander on the way to a comet. This is the future I want to live in, more of this humanity. Okay, well, that's quite inspiring. Thank you very much for this. And that is just the top of the iceberg. There's so many more tweets, but you can look them all up eventually. Once we finished speaking with these gentlemen here, let me just give you a microphone as well, because we have two. So we have here, obviously, Paolo Ferri, and you're looking much more relaxed right now at this moment than you did earlier today. Very good. The head of ESA's Operations Department, of course, Wolfgang Pitz, the head of the European Science Programs at Airbus Defence and Space, and Juan Miro, the head of Ground Systems Engineering Department at ESA. Good to see you all on stage. This time you have to stand, I'm afraid. So this is a great day for industry, for flight dynamics, operations. But if you had to pick the top 5 of all the amazing moments that we've already seen during this mission, what would it be, Paolo?
Well, for me personally, of course, was the wake up in January after 2.5 years of hibernation. Again, another thing that was never done before, and a thing that I hope will never be done in the future, at least by me. But no, this was a fantastic moment. It's top one, my number one. I don't know if my colleagues want to add.
Let's stick with the number 1 and go to the number 1 of Wolfgang.
Same for me. Waking up from the hibernation was the most amazing thing. We had to design hibernation to save power with this long swing away from the center of the solar system. And I mean, we gave these guys quite a headache, I think, because during hibernation, it's more or less like a controlled coma. Only the most basic routines in the onboard computer were still running, and they couldn't receive any signal. So we were all happy that it woke up again.
I remember that extremely well as well, this event. Do you have a different highlight, or is the wake up also for you the number 1?
No, for me it was actually today, when the orbiter was able to deliver the lander exactly on the trajectory to the comet. And this was a very delicate maneuver, as DG already mentioned. It is a matter of half a degree you are off and then you need to abort. And this was for me really the top.
Okay. Then the last one, you said a second one. Any of those that you heard already? Obviously not Wolfgang's.
Of course, for sure, the landing today is a master of the flight dynamics activities and all the activities coordinated across our center, the Cologne center, the one in Toulouse. It looks smooth, but it's not. And last night was not smooth. The previous weeks were very tough. It was really a highlight today. Yeah.
Okay.
No matter how it ends.
Well, gentlemen, my number 1 would, of course, be if in an hour from now we land. But otherwise, I'm absolutely with you. Thank you very much for coming up on stage. And, well, I can just only say we keep our fingers crossed again and again. Thank you very much, Paolo. Thank you, Wolfgang Pütz. Juan Miro, thank you very much for your time. Thank you. So some highlights and, of course, a lot of challenges, and all of this for one reason and one reason alone, for science. Now let's cross over to the Lander Control Center in Cologne again, which, of course, is one of the major centers outside Darmstadt, outside the European Space Agency, involved in the landing and science procedure. And there we see my counterpart, Uli Bobinger there. Uli, take it from here. Tell us about the atmosphere before the landing.
Thank you, Monica. Well, the atmosphere in the LCC, you can imagine, it looks like, well, let's say the eye of a hurricane. It's pretty quiet, very concentrated atmosphere, but no doubt about everybody here is in a flurry of anticipation. The scientists here in the Lander Control Center, they are waiting for the data, but not everybody is waiting. Some of them already got some data. Let's just have a quick glance what's going on here. I have here the Italian gentleman Pierluigi Di Lizia. What is your experiment, sir?
I'm here for SD2, the sample drill and distribution subsystem. So our goal is to take samples from the comet soil and distribute the samples to COSAC, Ptolemy and Shiva for further analysis.
So in the moment you are just still waiting because your experiments are starting when the landing has been accomplished.
Yes, actually we are going to be operated tomorrow. We are going to take 2 samples, hopefully to a depth of about 10-15 centimeters. Then we are waiting for the data, but tomorrow essentially.
For you, thank you very much. Let's have a quick glance at the DLR table where MUPOS, the multi-purpose science sensors for surface and subsurface science here is a responsibility here with Jörg Knollenberger. Mr. Knollenberg, how's the status in the moment for you?
Yeah, the status of the instrument is fully as expected. It's working nominal. We are running a calibration sequence for our infrared sensor head at the moment. You can see this here, for instance. There is a small heater is heated in front of the instrument to about 400 Kelvin from originally 200 Kelvin, and this causes this signal here in the instrument, which you also see zoomed here on the right plot. And this serves as for us as a means to compare with 15-year-old ground calibration data and recalibrate the instrument by this way and measure better surface temperatures.
This curve does look like maybe like your pulse speed. How's your mood now?
Yeah, it's very good. So far, everything is okay for us. We are very keen on then waiting also for the landing, because MUPOS has another important activity there. It should be noted that the harpoon is not only a means of tearing the lander to the ground, but it's also a scientific instrument. We have an accelerometer there on board, which can measure the hardness of the soil up to the maximum insertion depth of the harpoon, so up to about, hopefully, 1.5 to 2 meters.
So maybe, John, in 1 hour, a bit more, you will get from this already some data.
Yeah, we hope that we get the first, real scientific data from this event. And of course, also, we hope very much that we are safely anchored then.
Fingers crossed, all the best. And maybe we have one more gentleman here, Andrew Morse from Great Britain, with the Ptolemy experiment. So how's your status?
At the moment, our instruments is off and we are waiting for the landing. So we switch on about 10-15 minutes after landing to get our first science results on the comet.
How much coffee did you have already today?
Not enough yet. Yes, quietly nervous but confident.
All the best for you, and you will get the first sniff of the atmosphere with this experiment after landing on the comet. So the situation here, everybody is waiting for the touchdown and everybody crosses his finger. Back to you, Monica.
Okay, Uli Bobinger at the Lander Control Center in Cologne. Thank you very much for that sniff of the atmosphere there. Everybody is as excited as we certainly are. And the gentleman who is here with me on stage, Fred Janssen, the Rosetta Project Manager at the European Space Agency. I'm not even asking you how you feel right now, because we are getting closer and closer to this final moment, but I do know that Rosetta, let's not talk about the lander first. First about Rosetta is in a stable orbit, and all eyes are on the lander. But what exactly is happening next with Rosetta?
Rosetta is now maneuvering itself in a place that it can continue to monitor the lander while it's on the surface for a maximum period. And after that, it will fly orbits around the comet, such that we frequently fly over the lander and that we can communicate and send commands down and telemetry up.
And you're expecting to see something or get specific data in that time. What would that be?
A lot. It's the quick answer. Now, of course, we hope that all the first 60 hours is basically pre-programmed. That runs by itself in certain blocks, which we have to set up and allow to continue, etc. After that, there is a choice of what you can do. But of course, we hope that all the instruments will get their turn to get their science return and to tell us more about the comet.
I mean, the first 60 hours, there's this time limit of a battery also on the lander. A lot of things have, I think it runs for 70 hours almost, something in between. But time seems to be of the essence, not only now in those first 60 hours that you mentioned, but the mission as such is limited to 2 years. Is there a reason for that?
Well, when Rosetta launched, basically half of the weight was in fuel. And we've used a lot of fuel to get to the comet. I mean, the maneuvers we did this year to get alongside the comet were enormous. And but there is an end to the. So effectively, somewhere in August, September 2016, we run out of fuel. We start running out of fuel. But also, more importantly, we approach the same limit where we were when we exited hibernation, that there is not enough energy anymore in certain cases, and then we have to switch off Rosetta. So there is a fairly natural end to the mission towards the end of 2016.
Okay, a fairly natural end to the mission means a fairly natural end, one way or the other, to Rosetta and Philae as well, at some point, I should imagine.
Yeah, well, Philae, if we do everything right today, will stay stuck to the surface. And Rosetta, well, the debate is open. We're thinking about possibly parking it softly on the surface at the end of the mission, such that it will stay there forever.
So they're both united again. That would be a very nice thought.
That's the idea.
Project Manager at the European Space Agency, thank you very much.
You're welcome.
For telling us a bit about what happens after this big milestone that we're looking forward to right now. Thank you. Well, ladies and gentlemen, time check. Yeah. The clock is ticking. So we do still have time, just to tease them a bit more, to cross over now to the Lander Control Center in Cologne, where the Lander operations are monitored. And there we can see Koen Kurtz, the Lander technical manager, standing there in front of the glass wall that we've seen earlier today already. Behind it is the control room. Koen, I'm sure you're all tense and you're all very busy. I won't keep you long. Any wishes from you and from the team for what's happening next?
Yes, of course. Well, we're very excited at the moment. We just saw the image of Philae with all the legs deployed. Everything seems ready. We're very eager to start the touchdown window now and hopefully get the events that we landed safely.
We hope that too, Koen. Then I keep my fingers crossed for you, and I hope it all works out as well. Thank you. We'll check with you after the landing, of course, and see how you're doing then. Yeah. We also would like to check now with the Space Operations and Navigation Center in Toulouse in France, because they're also involved, obviously, in this mission, and there is quite a lot of activity I can see already, checking and looking at data. And we see here Philippe Gaudin, the Rosetta Project Manager at the French Space Agency, CNES. Philippe, I was told that le Président de la République is keeping a very close eye on what's happening today. He's watching you live from Paris, probably as we speak. So I should think that, apart from everything else, you're even more excited about this touchdown, hopefully very soon. And your team in Toulouse has provided the orbital calculations for the descent. They've provided the procedures for the instruments, and they will provide us with the first images. Some of them we'll hopefully see very soon. All in all, a great day. What do you think?
Yes, it's sure. As you say, we are here very excited, but also very stressed by the pressure we have with the president, but with the event of today, of course. But I have to say now that I'm very confident, because I see that our center is working well, Philae on board is working well, and we are waiting here now the next science data, and it's, for example, the release image is taken just before the landing. So I want to wish a good landing to the lander, to Philae, but I saw that the landing gear is deployed, and that I am confident that we will succeed.
That sounds great. I wish we all had your confidence, but thank you very much for sharing this with us. Philippe Gaudin from Toulouse, thumbs up, and yeah, best of luck. Thank you very much. So let me just find out, this gentleman who's joined me on stage now, Matt Taylor, of course, the Rosetta project scientist at ESA. Are you as confident as the gentleman we just spoke to in Toulouse? What do you feel right now?
I'm knackered. But I'm also very, very excited. We're getting very, very close. We're all going to be very emotional. This is it. We're close now. We're very close.
Well, you're knackered, and I feel really terrible, but I still have the time to ask you that question. Oh. And maybe it'll actually help you to calm your nerves, so, because yes. This has been a long journey. What have we seen in these past 10 years?
Yeah, we haven't been doing nothing for the last 10 years. We've had an incredible journey. We've gone past Mars. We've gone past the Earth several times. We even visited a couple of asteroids. We were doing science on those occasions. We were able to combine measurements from Rosetta, the cluster mission as we were going past Earth, with Mars Express as we went past Mars. We were also coupled with Earth observation satellites we went past Earth. And of course we had the Steins flyby, the Lutetius flyby, then the hibernation, then we get to this year. So we've been doing stuff all of this time, and it's been a fantastic journey. We've seen things originally probably people wouldn't believe, to quote somebody, and we all believe it now because we're here.
And this has been a particularly busy year. Matt, you're knackered.
Yeah.
I will not stress you more.
It's a busy year. It has been a busy year. I'm actually 25 years of age, but I look 41. Yeah, we came out of hibernation. We rendezvoused. We ticked that major milestone. We started orbiting around a comet. That's never been done before. We characterized a comet that we didn't even know what it looked like earlier this year. Now we know intimately what it looks like, and we're about to try and get even more intimate with the comet. As Gerhard said earlier on, we're moving in for the kiss.
Moving in for the kiss. All right, well, then you better take a deep breath now, Matt, and get ready for that kiss.
And some breath mints. Yeah.
And some, well, that's the comet. The comet needs the breath mints. We heard that earlier. Matt Taylor, thank you very much. All right. I hope you can still cope, because before we go to the MCR, in order to then watch as things unfold, and this could take up to 45 minutes, so be patient. We still have a few minutes to check the last tweets. And I wanted to do this actually together with a gentleman who is coming now very energetically. Here he is, Mark McCaughrean. He's the Senior Science Advisor to the Director of Science at ESA. I've got it now on my piece of paper. It's correct. There's huge interest. We've heard about it. You've brought your own tweets with you.
I have. I've got the worldwide trend map here. And, you know, there is not a country in the world where it doesn't say hashtag Comet Landing, hashtag Philae 2014, hashtag ESA Rosetta. It's awesome. Thank you very much, everybody who's out there doing this for us today, and we hope to deliver for you a little bit later on. Thank you.
Well, thank you very much for bringing this, and here we are. We have to, or we would love to go through this, because we've got all these people up here just as a glimpse.
Well, the first one doesn't need answering, that's obvious, right? Who will play the lead in the movie about today's attempted landing? Gives me shivers. 500 million kilometers from Earth, a human-made robot. Two of them, remember. Two of them are out there, and one's doing the landing right now. You know, this is all over. It's everywhere. This excitement is just astonishing. And it's this engagement that we have from this mission, which it's not only about the exploration, it's not only about the science, it's the inspiration of the next generation. And this is really what's important here today.
It is.
Grabbing hold of everybody. So again, thanks everybody else. And
yeah, and then they just keep William Shatner, where Bill. We go boldly where no one's gone before.
Absolutely.
Wonderful. Captain Kirk, I salute you. Wonderful. Tracy Hill, fingers crossed, only
Thank
the
you,
best
Tracy.
wish.
I recognize you there, Tracy. Welcome.
Oof, now they're really pouring in here. Wonderful. Massimiliano Malerba, this is not just a European mission. I'm Italian, I wouldn't have guessed. This is an outstanding endeavor for all mankind. We're all on board Philae. Ooh.
So,
gives you goosebumps. You've got goosebumps, I know.
Just everywhere.
You are a goosebump now.
I'm one live goosebump right on stage, right here.
Okay, Mark McCaughrean, I will not keep you any longer. Sit down.
No, it's next.
Yeah, it's right over. It's right over there, and we are getting ready to basically cross over for one last little chat with a gentleman who may be now a bit more tense than earlier in the main control room with the Philae lander manager from the German Space Agency, Stefan Ulamet. And there he is.
Hello.
Stefan, one last word from you before we all sit back in silence and watch.
Well, the touchdown window has started for our systems. So the lander in principle is now prepared that every second we could hit ground, so we have a slightly larger touchdown window assumed to be on the safe side than what's really realistic. But, well, as you can see, 36 minutes to the nominal touchdown. That means, in reality, we are just about 8 minutes away from the real landing. Of course, that's getting very tense and very exciting now to see the actual touchdown and then also get the confirmation that the harpoons have been fired and get the first data from the surface of the comet.
Stefan Ulamet, everyone here in this room has their fingers crossed right now. And thank you very much. Up until this moment, kudos to you and the whole team for getting us to this point. And now we're all waiting to see the culmination of this mission, the landing on the comet Churyumov-Gerasimenko. I would just say, everyone, fingers crossed and good luck, Philae.
Thank you. We need this little piece of luck for sure. Yeah, thank you.
Well, the moment has come. I will eventually stop commentating and take seat somewhere amongst you in order to sit back and watch history unfold. We will get ready now to cross into the main control room to see those faces, the tense faces, and hopefully then within the next 45 minutes, maybe even sooner, 8 minutes was a possibility we just heard, to see smiling and cheering faces. A historic event, the landing on a comet 500 million kilometers away in space. Let's keep fingers crossed, or in German, Daumen drücken, thumbs up, whatever is necessary. We cross now and watch.
In reality, we see it 38 minutes after. Yes, the countdown is 32 minutes and 20 from touchdown. No. You heard me there. 54 seconds. Okay.
For these new TMT lots that are triggering now because we confirm that we started receiving. That's it. Sorry. Yes.
I don't want to spend another hour to set it up. So we have a slide with is the current of the landing gear of the airplane. So the ESA they are doing the the AMD which is not very much, but the parameters of the because on the best we go to say the law just a word on the live on the web. Yes, everything you are saying. It's a bunch of coordinates at home, and they have everything. So well,
It's the redundant one. The nominal one is
nominal is 1385.
Link is still coming.
Yes, okay, just changed. So there is telemetry coming.
Yeah, there's telemetry coming for the
Because otherwise it would have bounced. If it would have bounced, we would have lost it.
Yep. Okay, this one is not going down though. The lander, the elevation did not go down.
It's the same
by the way,
resolution
but
as-
it's probably due to the 4 minutes polling.
3501 it was.
The time of the packet.
Yeah. The must. And when did we observe the vision? Remember the time when we saw the signal?
Yes, definitely something we can say. We're still looking at how it's behaving, but we have telemetry, so. Yeah, maybe. Andrea, do you want to make a statement? No?
Yeah. Is anybody talking to me? I get
Steve,
it.
you get it.
Am I already live?
No,
Yeah,
no,
it's coming down. Yeah, it's coming down.
Yes, good.
When you touch down, the machine lowers it.
OD to all station, we see the lander anchoring and sitting on the road.
Okay.
I
I don't have to earplug, no. Nobody
But I can hear you.
They can hear me, I can. Okay.
We are live, I guess. So we can't be happier than what we are now. We definitely confirmed that the lander is on the surface, and I leave it to Stefan. I think it's up to him to judge how it's going now on the lander.
Okay, so we are there, and Philae is talking to us. First things he told us was that the harpoons have been fired, rewound, and the landing gear has been moved inside, so we are sitting on the surface. Philae is talking to us, more data to come and to be analyzed right now. The flywheel is going down, which it should do, of course. We are there, it's done its job. We are on the Comet.
Ladies and gentlemen, Philae's on, and clearly a few very exhausted and overtired, but nevertheless very happy flight directors and operation managers there in the main control room just now. Ladies and gentlemen, there are some very happy people standing here, all eager to say their bit. First of all, I would like to ask Jean-Jacques Dordain, the ESA Director General, on stage. Monsieur.
So difficult. So Jean-Pierre, c'est interdit de boire ici. Hein? Bon, okay. You have all heard that Philae has landed. And to take what Professor Churyumov was telling us, this is a big step for human civilization. And because this is science, scientist, knowledge, and that this is certainly terrestrial intelligence. That makes the difference. I would like at this stage to repeat what I say after each success. The biggest problem of success is that it looks easy. And especially for us who are not doing anything. And when you know the sum of expertise, the sum of dedication, the sum of team working between 20 nationalities of member states of Europe, plus cooperation with international partners. When you know that this type of success is not coming from the sky. It comes from hard work and for expertise, because the only way to reconcile risk and success is the expertise. This is the reason why today we have demonstrated that the European expertise, be it at ESA, be it in the industry, in national space agencies, in research centers, everywhere, this is the best expertise of the world, because we are the first to have done that, and that will stay forever. Thank you very much.
A big and certainly very emotional day for the Director General of the European Space Agency, Jean-Jacques Dordain. Ladies and gentlemen, the European Space Agency is based in Darmstadt. Darmstadt is a part of the German state of Hesse, and we have the Prime Minister of the state of Hesse here with us. He's also the President of the German Bundesrat. Welcome, Volker Bouffier.
Sehr geehrter lieber Professor und Präsident Dordain, verehrter lieber Professor Wörner, Professor Reiter, meine sehr verehrten Damen und Herren, das ist ein Tag der Begeisterung, des Glücks und der Faszination. 500 Millionen Kilometer von hier, unvorstellbar, findet etwas statt, was jedenfalls nach meiner Kenntnis zum ersten Mal überhaupt gelungen gelungen ist. Es ist wirklich epochal. And it is, like you mentioned, it looks very easy, but it isn't easy. It's, in my point of view, a miracle. And the result of a great work of all of you and a lot of colleagues who are today not with us. But my warmest welcome to all these colleagues, the science community, the honorable guests from all over the world. And I may say, in this day, Darmstadt is the middle of the space agency, and we are very proud here in Hesse and in Darmstadt. That at the end of this mission, or Rosetta mission, longer than 10 years, the most powerful and the most, in my point of view, the most exactly doing was here ESA Darmstadt. And therefore, it's a great day for all over the world and for Space Agency. And it's a special day for us. And we are very proud to can share this day and this event with you. My congratulations to all those who has done such a huge result. You compared it sometimes like the first time on the moon. Maybe. I hope that we will get a lot of informations that will make the world a little bit better. In this way, thank you for coming. Congratulations for this huge event and huge result. And all the best for ESA and all the colleagues who have done this wonderful day. Thank you.
Thank you very much, Volker Bouffier, the Prime Minister of the State of Hesse, the home state of ESA in Darmstadt. Now, ladies and gentlemen, next we will receive a message via video because the lady unfortunately couldn't be here with us today, but she's been here for many Rosetta events, and I know she's very interested in it and has been following a lot of European Space Agency missions. So we now look forward to the message from Brigitte Zypris. She's the aerospace coordinator at the German government. So let's listen in.
Congratulations to all of the scientists and engineers that have been involved in making this landing a success. The landing is an outstanding achievement. Nobody knew what kind of conditions the lander would be faced with when it was developed more than 10 years ago. And the unusual shape of the comet has made its landing a particular challenge. Philae can now get on with its important task of conducting scientific investigations. We are hoping for nothing more, nothing less than to find out more about the formation of our solar system. And of course, about water, the most important question, as we could see in the short film about Rosetta Ambition. Ladies and gentlemen, I'm very glad that the public has also shared in the excitement of this mission. There has been an immense amount of interest shown, of course, particularly today upon Philae's landing. Millions of people right around the world have been following the landing per live stream. And there has been a large number of events taking place in many different countries. This interest of the international public also shows one important fact. No European country alone can realize a mission of this scale. We can only do it by working together.
And that was congratulations from Brigitte Zypris, the aerospace coordinator of the German government. Our next speaker is here on behalf of a gentleman who could not come. He's on behalf of Mauro Del Ambrogio, the vice chairman of the ESA Council at ministerial level in Switzerland. And here to speak on his behalf is Daniel Neuenschwander, head Swiss Space Office, State Secretariat for Education, Research and Innovation. Welcome, and we're all ears.
The statement from the State Secretary just received was wow. Wow, and now deliver 4 times thank you in 4 languages. So I will do my best. I think it's not only saying thank you, it's also committing us all together for the future. But let me first say, Rosetta is an absolutely great scientific success, pushing the frontiers of knowledge and demonstrating what ESA, with all its partners, delivers. First mission to get in orbit around the comet. First vehicle to accompany a comet towards the inner solar system, and now we know it, and first successful landing of a man-made object on a comet. Wow. And with the most elaborate navigation techniques and with world-class precision and approach maneuver. I think we cannot thank enough all the engineers and scientists and people working behind this. As it was said, this requires a decision. And the decision on Rosetta, we all know, was decided in 1993, launched in 2004. Now we are here. I think there is a lifespan of about 25 years between preliminary studies and the end of the mission lifetime, which is not today, of course. Danke für die Bereitschaft zum Risiko. Danke für den Durchhaltewille. Cooperation on Rosetta. Rosetta is a proof of a great cooperation that worked over time and that delivers results. I cannot state it sufficiently enough. Cooperation with 15 European states and partners from the United States, from Canada and Australia. We can only underline today the value of international cooperation in space, since there is no alternative to cooperation if humankind wants to advance in its exploration of the universe. And we have demonstrated that we, Europe, we are in the first row. So, thanks to all people who dedicated a considerable lifetime of their professional lifetime to Rosetta, and we have the privilege to witness a global premiere today. It is for the first time that we, as we said, we landed on the comet. Thanks to all of you and for your dedication. Let me add one point. There is also the technological and operational challenges which we saw today. And I think it's very important. We can scientifically look back to 4.6 billion years. We can investigate about the oldest building blocks of our solar system, and it will probably help us to answer fundamental questions about the origin of our life. The scientific data that has been collected so far by Rosetta are outstanding, and the mission is already since months as a great success. Merci pour cette moisson scientifique, et merci aussi pour l'inspiration pour les nouvelles générations qui a été donnée aujourd'hui. It was said by the German State Secretary Zypris, we can all do this when we work together. I think it commits all of us, it commits the co-presidency of ESA at ministerial level, and I can only close by grazie per tutti, forza Rosetta, forza ESA.
Mille grazie. Daniel Neuenschwander, the head of the Swiss Space Office. Our next gentleman that I'm calling up on stage, I remember very well part of his speech ahead of the wake-up call in January. He was the one who quoted some of these iconic TV sci-fi sentences, space the final frontier, or to boldly go where no one's gone before. And I would imagine he will have been as thrilled as myself seeing none other than Captain Kirk tweeting meeting today when the landing was about to happen. But that isn't the only reason why he should be thrilled. His operation played a major role in the success of the Rosetta mission. So we're looking forward now to hearing your words right now. Jan-Dietrich Werner, chairman of the board of the German Aerospace Center, DLR.
Thank you very much. I can tell you I'm even more thrilled than you are reading from Chetna. Ladies and gentlemen, it's in fact a real, not only an honor, that's always what is said, an honor and pleasure. I'm really happy. I'm so happy to witness this success, a success of cooperation in Europe, which was said. It's a success of ESA as a whole, but at the same time also at the partners for the Philae, namely ASI, CNES, MPS, and also DLR, and of course NASA. 7 years ago, I entered DLR, and in the first days, I got an explanation of this strange mission, Rosetta. And I'm telling you that story because it's very important. They showed me the instruments, they showed me the lander model at the place where now we have also this control center in Cologne, and I just said, I'm a civil engineer, it's unbelievable. That you cannot think about it, that's not possible. And then I went away. It took 3 years until some of the scientists came back to me and said, Mr. Werner, we are not happy about you because you don't believe in us. And that was not what I wanted to say. I wanted to say that this plan of this mission is so exciting that I cannot really understand that it's possible. Today, you made it possible. Therefore, as Daniel was saying, grazie, merci, thank you very much, and vielen Dank.
I want that polo shirt. Wonderful. Well, ladies and gentlemen, not now. We've got a few minutes. Not now. Changed. Well, that's an okay. Stop flirting. I still have a job to do here. We have another message, this time coming in from Jean-Yves Legal, and I heard it only happened just now, so let's not make him wait and listen to it right away.
Monsieur le Président de la République, Mesdames les ministres, Mesdames et Messieurs, chers amis, je crois que l'essentiel a été dit. C'est un jour qui est absolument extraordinaire. Moi, j'ai un souvenir qui est très précis, c'est que, comme cela a été rappelé, Rosetta devait être lancée le 12 janvier 2003. Et en fait, nous avions eu peu de temps auparavant une difficulté sur Ariane et nous avions dû décider de repousser ce lancement d'1 an. Et à l'époque, évidemment, il y avait une déception de la part des scientifiques. Eh bien, je crois qu'aujourd'hui, cette déception est largement effacée parce que nous avons une mission qui est, je le disais au Président, probablement l'une des missions les plus importantes de l'exploration planétaire depuis le début de l'ère spatiale. On s'est posé sur la Lune, on s'est posé sur Mars, on s'est posé sur Vénus, on s'est posé sur Titan, mais c'était des objets qu'on connaissait parce qu'on avait pu les observer avant de s'embarquer pour là. Là, la comète, on ne savait pas ce qu'était ce noyau. Et c'est seulement le 6 août qu'on a vu cette forme assez bizarre. Et ensuite, nos équipes, à l'Agence spatiale européenne, dans l'industrie, au CNES, tous les scientifiques qui travaillent sur ce projet ont dû calculer, affiner des modèles. On a développé jusque, je crois, on me disait, 1 milliard de trajectoires pour savoir laquelle serait la meilleure pour se poser. Eh bien, démonstration est faite que ça a marché. Donc, je voudrais vraiment féliciter l'Agence spatiale européenne, toutes les agences pour le lander Philae, il y avait le CNES, il y avait le DLR en Allemagne, l'ESA en Italie, les scientifiques, parce que sans les scientifiques, ces projets n'existeraient pas.
Without the scientists, this project would never have got off the ground. So, President, I'd also like to thank you for the support that your government has given to this space mission. This has been consistent for a long time now. Philae was encouraged by Professor Curie and François Mitterrand going back a number of decades. But today you are here to see the landing. So, bravo. now we look forward to having a few additional explanations with the first images of Philae. As I said, we were waiting for the landing. It was complicated, but I think now, it's going to be rather easier to get some pictures. So, bravo, well done. Thank you.
Merci infiniment.
Thank you.
Bravo encore aux équipes du Centre national d'études spatiales. Frédéric Castel en direct de Darmstadt.
Attends, excuse-moi, je vais t'interviewer.
Monsieur le Président was at hand as Monsieur Légal. My French isn't that good, I'm afraid, but from what I heard, he was citing on various successes that this corporation has already achieved and obviously praising this very success. Well, ladies and gentlemen, I'm sure there would be so many of us who would like to be up here and say their thanks. We can't do one after another, but I've got 4 more gentlemen that I would like to have here on stage right now. Roberto Battiston, David Parker, Jim Green, and Michael Manking, if you would like to come up. I leave the order up to you.
So, a small jump for the robot, a giant jump for mankind, and from Europe. So we have now Philae, which is gently landed on Alikia, this strange place in a strange world, as the result of so many years of collaboration, was mentioned many times, so I will say it also, between DLR, ASI, CNES, and all ESA together, working for tremendous success. And the fun is now beginning because the science of this tremendous journey is going to start. Coming in this beautiful location, a few months ago, we had the similar meeting where for the first time we saw it from close by. And coming in, I saw this image, and it looked familiar. Just few months as something completely unknown is just part of our understanding, part of our culture. This is science, which is developing very quickly, and this is a demonstration how quickly we are moving in spite of the time it takes. So, in the past we had a number of myths, which are starting from going to the America, looking for the North Passage, looking for the South Passage. I think going to the comet is now part of this historical decision, goals, difficult things which humankind is so good at doing it. I always dreamed to be at the beginning when a myth is starting. This Rosetta is a myth, as was a myth many stories that in the past were told and described by poets and by historians. Today, the technology allows us to live through this occasion with a much more effective way, with much more images, but the core of it is the same. It's about human beings. It's about us. It's about people having a dream. It's about working together. It's about dreaming for the future. And the fact that we are so fragile, so small, so weak, but we can do things like that, obviously make us very proud of belonging to this fantastic race. And so this is just the beginning of the adventure of Philae, but this is also the beginning of ESA landing on foreign bodies. So thank Philae, looking for the beautiful science you're going to create, and let's prepare for the next time. Let's prepare for ExoMars. Thank you so much.
Well, good afternoon, ministers, distinguished colleagues, friends. I send the congratulations of Greg Clark, the UK Minister for University Science and the Cities. I know he's been interested to follow this mission. Unfortunately, he could not be here today, but I'm sure he is following the success from a distance. Everybody talks about the imagination and vision of missions like this, and they stretch over generations. I almost think of them as being a bit like the great medieval cathedrals. The vision is passed from generation to generation, but the legacy and the legacy of the science we'll get from this mission will last forever. But to have that kind of vision takes a lot of people, and I think it's the people I would like to say a few words about that have delivered this project. Jean-Jacques, the Director General, has already spoken about it, but many of those people have been in the UK and have contributed to this mission over the years. In fact, amazingly, I was told the very first science meeting about this project was held as long ago as 1986 in the UK, and even the very first Director General of the European Space Agency was at that meeting. It's been a generational project. So the scientists had the vision for the mission. The engineers and the technologists got involved in helping build it, so I'd like to express my thanks to the people in UK industry who have helped contribute to the project. And then right now, I know there'll be scientists from the Open University and the Rutherford Appleton Lab that will be celebrating because their contribution to Philae, this miniaturized laboratory that's now on the surface of the comet, has been their contribution. But to some extent, the success for me is tinged with just a little bit of sadness because the scientist who proposed that instrument, Professor Colin Pillinger, sadly passed away earlier this year. And he was a leading proponent of planetary science in the UK, pushed the UK to take planetary science more seriously. And although my thoughts go out to his family, I know one thing, that Colin was enthusiastic about the effect of exploration and planetary missions to inspire the next generation. And so I worked on Rosetta 20 years ago as a young engineer. And if there are people and students and kids in school today, imagine what the projects they're going to be working on in 20 years' time. So the simple way of summing it up for me is science fiction has become science fact today, or a better way maybe is Hollywood is good, but Rosetta is better. Thank you.
Good afternoon. I'm Jim Green from NASA. And on behalf of Charlie Bolden, the NASA administrator, and John Grunsfeld, the associate administrator of NASA in science, I congratulate ESA. And in this congratulation, it's critical to understand the role that ESA has played in making this mission happen. The number of countries that are involved is more than any other mission that I can remember. We're very proud to be a part of this mission. We have several experiments on the orbiter, and it's just been wonderful. I'd also like to say a couple things personally. From my perspective, how audacious, how exciting, how unbelievable to be able to dare to land on a comet, to take that step that we have all wanted from a scientific perspective. You know, this mission that ESA has produced and given it back to the world in this venue has allowed us all to participate in that great adventure. We should relish that moment. It is the start of something important. The solar system is mankind's. This mission is the first step to take it. It's ours. Let's learn about the environment that we are in. It's these steps that will lead us beyond this planet and onto Mars and out into the solar system. I truly believe that a single planet species will not survive long. It's our destiny to move off this planet. And this is the kind of steps that we must do. ESA, thank you from the bottom of my heart for a wonderful experience. And the science will be marvelous. Thank you.
Ladies and gentlemen, my name is Michael Menking. I'm representing Airbus in the industrial team. What a great day. And I can only confirm the Rosetta mission is another giant leap for mankind. If you consider how many first times we had, and perhaps we even will have in this mission, because for sure the landing is a very important subject, but it's not the end of the mission. We will at least follow the comet for the next 1.5 years. For sure, we at Airbus are very proud. We built the spacecraft. We are proud being a part of the engineering heart. And thanks, therefore, to ESA, who has entrusted us to do that job. And just taking my ingoing statement with a giant leap for mankind, we hope that Rosetta mission will inspire the next and young generation to go to space as Apollo has inspired us. Just to give a short look on the international cooperation we had also on the industrial level, and to give you some figures. Airbus Defence and Space here in Germany, in Friedrichshafen at the Lake Constance, had the lead team, had the prime contractorship for working together with more than 96 companies all over Europe, nearly in all member states, including also working together with the US. Each country has put their own contribution into this mission, and this also shows it's not just, let's say, one focus, it's really a common international endeavor. So therefore, I would like to thank all the contributors, all our partners, contractors, suppliers for their contribution. Be aware that the lessons learned, the skills, are still in the brain of the engineers and are used for sure for other missions mentioned by ESA, like Bepi Colombo and like others. So therefore, that's in. Thank you very much for that, and thank you very much for the trust which we got from ESA. Thanks.
Thank you. Thank you very much, gentlemen. And ladies and gentlemen, if you just have a few more minutes, because before we can open the champagne, I think it would be very kind towards Philae if we just one more time make sure it's okay.
We take an image. It was exactly planned 50 seconds after the release, and it worked perfectly well. And we take an image that just arrived here, so it's really not processed, it's really as it is. The problem is that we have the sun in the window, if I can say so. So the sun is illuminating everything here, so we have a lot of scattered light, which is not important. It demonstrates the quality of the image and the dynamics of the image.
So we have the first images taken by the orbiter, by Osiris, coming down straight these minutes.
We definitely confirm that the lander is on the surface, and I leave it to Stefan. I think it's up to him to judge how it's going now on the lander.
Okay, so we are there, and Philae is talking to us. First things he told us was that the harpoons have been fired, rewound, and the landing gear has been moved inside, so we are sitting on the surface. Philae is talking to us, more data to come and to be analyzed right now.
announcement because we're kind to you. You can imagine this was a very, very crazy, a very busy day, even for top scientists here at the European Space Agency. And they are giving interviews non-stop, very, very busy. And they're very, very busy working on all the data that they receive, which is why we have to postpone what we wanted to do here to 8 o'clock. So only about 20 minutes from now. So if you want to get another glass of wine or whatever, or chat or do whatever you want to do, All right. Good evening, ladies and gentlemen. 10 minutes over time now, but then again, I think today we have a fantastic excuse for this. Most of the people that we expect now on stage to present one of the first images of the lander have been working pretty much 24 hours non-stop, if not longer. You've witnessed them for several hours today and yesterday evening already. They're very busy giving tons of interviews, but they're here with us now, and so we can give you this last brief, media brief that we had promised. So, ladies and gentlemen, first of all, at this moment, I would like to call on stage Jean-Jacques Dordain, the Director General of ESA, to give us a first update.
Okay. Thank you very much. So, it's a great day. Great day, not only for ESA, but for, I think that for the world. What I can say that we landed, and Philae arrived to the landing. We have landed at the right place. It's also the right comet, don't worry. And we have got the radio link, which is obviously very important. And we have the power on board. So when you have the link and the power, you collect data. And colleagues are doing. You collect data on the spacecraft, on the lander, and you collect data from the scientific instruments which are already working. So that's what I can say. Now, the data have to be analyzed. This is only less than 3 hours that we are on a comet at 500 million kilometers. So you have to give some time, and I have to give some time to my colleagues to analyze the data. So they will give you the last news that they have on the data, but I wish that we are careful because we are just at the beginning of something which will last months. And again, we have everything, we have time, and now we have just to work. So I shall now give the floor to the workers, and I think that I give the floor first to you. No, to Stefan. Okay. So that is one of the scientists who can give you his data because they belong to him. And so I give the floor to Stefan, and after I shall give the floor to the two persons who are in the control center. But first, the scientist, because we are doing that for the scientists. So thank you very much.
Thank you very much. So my name is Stefano Mottola. I'm responsible for ROLIS, the descent imager on board the Philae lander. So we're very happy to see that we're starting to receive the data, and we got the first image taken during the descent. The image was taken at a distance of about 3 kilometers from the nucleus, and this is it. On the top side, we see a leg of the lander, which is in the field of view. And as I said, the size of the comet taken from 3 kilometers is about 3 kilometers in size, and we have a resolution of about 3 meters per pixel. The landing side is exactly in the middle, so we can confirm that the trajectory was correct, and we had a safe landing, and more images are to come. Thank you.
All right, Stefano Mottola, PI of the ROLIS. Thank you very much for presenting to us. I know you've been working really, really hard in the PISA room, and you still have to keep on working to get through all the data, but thank you for taking the time to come here now and present this picture to us. Thank you very much. And now, of course, there are two gentlemen. We've seen them sweating blood and tears all day. Stefan Ulamet, the Philae lander manager, and Paolo Ferri, the head of ESA operations. Stefan, let me ask you first, what's the latest?
Okay.
It's complicated to land on a comet, and it's also, as it appears, very complicated to understand what has happened during this landing or after this landing. Now, what we know is that we touched down, so we landed at the comet at the time when you all saw us cheering and when it was announced. We had a very clear signal there, and we also received data from the lander, housekeeping data, and also science data. That's the very good news. Not so good news is that the anchoring harpoons apparently did not fire. So the lander is not anchored to the surface. And now we started to think about what could be the situation. Did we just land in a soft sandbox and everything is fine, although we are not anchored, anti-ADS did not fire? Or is there something else happening? And we looked into the data. And indeed, it's interesting, and we still do not fully understand what has happened. So whatever I'm telling you now is a little bit of speculation. So maybe you take a night and think about it, and maybe you come up with another good idea by tomorrow morning. So we had fluctuations in the radio link. Not perfectly regular, but some kind of fluctuations. The signal always came back again immediately, and we were continuously not very good data already. The Kozak and Ptolemy people are very happy. Well, Rollis got nice images, which will soon be, as I suppose. So this instrument worked very nicely. Also Sesam worked very nicely. Mupus, we got some data. So we have plenty of data. Some of these data, also Roma, indicated that the lander may have lifted off again. We touched down, we're rebouncing very slowly because the landing gear worked perfectly well and it was designed in order to damp the majority of the impact energy. What we saw in the coming about 2 hours was fluctuation not only in the RF link, but also on the solar generator, which could be interpreted, again, don't cite me, that's what it is. It could be interpreted that the lander lifted off and started to turn itself because the flywheel was switched off at touchdown, so the lander would start to turn. About 2 hours later, this information of turning on the power generator stopped. We still got radio link, we still get science data from there. So maybe today we didn't just land once, we even landed twice. Okay. At the moment, the radio link is gone again, which is not so surprising because Rosetta is behind the so nominally we will operate now the concert instrument, the tomography, and tomorrow morning, if we re-establish the link and we get the Kozak results, the concert results, Kozak we already got some data, we should know much more, and hopefully we are sitting there on the surface at the position slightly different to the original landing and can continue our science sequence. As I said, everything a bit speculation right now, but this is the status. People in LCC, also in Song, are busy in interpreting what we get, and it's not all so clear, it's not so easy to interpret, but tomorrow morning we should know a lot more.
What do people say? If it was easy, then it would not be rocket science.
Exactly.
But in this case, that's not the case. Thank you very much, Stefan Ulametz, for this update. Fantastic. Thank you so much. Paolo,
yes.
Operations.
Right, so what else can I say from the ESOC side? These guys are very busy analyzing the telemetry, and we just left a meeting where jointly the people in the 3 control centers were exchanging information to come to solid conclusions on all the speculations that Stefan was mentioning. On the ESOC side, I can say we have all good indications, although not an exact number now, of a very precise first landing. Also, we use the, well, not we, but the camera teams use the ROLIS images to confirm that we landed very, very close to the original planned center of our big error ellipse. So the error ellipse was eventually, the real error was much smaller than the error ellipse. That we can state, we will be more precise. I think the song people have already the exact coordinates of the first landing. We lost the radio link earlier than planned, which is something that we never like, but this is not at the moment concerning, because depending on the orography, this estimation on the Rosetta was going below the horizon, and so when you have a horizon with hills and boulders and whatever, it is expected that your estimation on the end of signal is imprecise. So we have now
thank you, Paolo and Stefan. And just to say that the mission is a success, I don't need to look at computers or don't look at data. And I am just looking at the smile of Paolo and Stefan. And when they are smiling, it means that this is a success. It's a big success, and it was a great day. Thank you very much.
Thank you, everybody, for staying with us for such a long time. Some of you, perhaps, for all the 24 hours non-stop. Thank you for your interest. Spread the good news. Philae has landed. Philae is alive. And all the rest we will tell you tomorrow at 1400. I wanted to show you all the people who guided us through these 12 exciting months, but they're all very busy. Matt Taylor, Holger Sergs, they would all like to get your applause. Please give them your applause, even if they're not here. They've done a really great job. And now it's time to have a drink. I'm signing off. Thank you very much.